So we're here to talk about this morning Google App Engine. And I want to make this a very two-way conversation. I'm going to invite some people to come down, set some things up, actually try it hands-on, so it's not just going to be me. That would be boring if this was a lecture for 3 hours. So this is going to be hands-on stuff and an opportunity for you to ask questions. I'm the type of person who loves it when you interact and ask the things that I can add meaning to. If it were just a set of prepared materials, why would they bother to brought me here to give this talk? So use the opportunity to please raise your hand, wave it so I see you, jump in, ask the questions that make this useful to you. If it's just prepared materials, then I don't feel like I've given you the best value that I can. So the opportunity is open at any time for you to ask those questions. But I've got a lot of good stuff to help us seed the discussions and talk about the facts and operations of Google App Engine, and we're going to set up a couple accounts as well. I'm going to check my Wi-Fi to make sure that we're hooked up with that just before we get started here and make sure that that is good to go. And if it is, then we will have fun with a lot of live demos. Fingers crossed. Excellent. I'm very pleased. There we go. So Google App Engine, a couple of things. This is about me. I'm a very non-important person in that sense. I am here just to be a resource for Google App Engine today. Who cares about what I do in the past? I've just worked a lot with Google App Engine, and I guess that's all we need to know for the beginning. The structure today is 2 90-minute sessions with a break in the middle, and that means we have a lot of ground to cover and a lot of cool things to talk about. Now, you might want to start off with a history lesson. I am always tempted to do that, but you know what? We're developers at heart, so I thought about this, rearranged this. We are going to go hands-on and just show code, show what happens, show the tooling, dig into it. We're developers. That's what we want to do anyway. So let's start by building an app. Did you expect to do that in the first 30 seconds to 60 seconds? Probably not. At least I hope not. I hope that's a surprise. What do we need to do that? We need a couple of different things. The first thing that we need is the Google App Engine Sdk. So this is very important. You cannot really start with this platform until you download it. It's a relatively small zip. It's in the dozens of megs. And you grab it up from the page. All these links will be available from the downloaded slide deck. I've got them all over to the GIDS folks. So you've got all the links. Don't worry about the individual addresses. All of that will definitely be sent to you. But here's the download page for the Google App Engine Sdk. It's about 26 meg. Grab a copy of this, and we're going to look through what's stored inside this set of folders. What does this give you? What's the tooling here? Now, a couple of other funny things that you also need, and we're going to put some context as to why you need those as well, is the Google Web Toolkit SDK. Web Toolkit? App Engine? I don't understand, but you will. It's kind of strange that they require you to have that as well. But there, we're going to go grab a separate copy of that and download it to yet another folder. So we've got the Google Web Toolkit. We've got the core SDK. You've grabbed a copy of that. And really, for maximum productivity, you do not have to have this. But for good productivity, go grab the Google Eclipse plugin. Now, you notice generically, it doesn't have the word in there that says Google App Engine plugin. This threw me for a little bit in the early days when this was first getting started. I'm thinking, I want the App Engine plugin, not the Google plugin. I don't want to search the web. I'm looking to build a tool. But they actually have just one unified plugin that offers a lot of different services in terms of GWT and the App Engine behavior both. So they're all bundled into a single plugin. So we've got that established nice and clear. You can grab that. It's got an update site. I recommend working with Eclipse 3.5 or even the 3.6 beta. It works well on both of those. 3.4 and earlier, it's got some strange behaviors, and they're really not giving it a lot of attention anymore. So I would say that your focus, if at all possible, should be 3.5 or higher for the platform. So let's go ahead and write some code and take a look at what we would do with this. And I am going to fire up, wonderful feedback, I'm going to fire up the IDE and go through what we would do to publish an app at this point. So I'm going to tab over to Eclipse, which I have fired up. I'm going to drop out of this. I'm going to start brand new. Let me give you a little bit of a view, and I'll do some nice zoom-ins here, but feel free to shout out if we need it larger. Where I'm going to start is up here in this corner, and by adding that Google plugin, I get this item on the toolbar. Sure, you can do File New, but that's nice and convenient. New Web Application Project. Again, the thing that kind of threw me, and maybe I'm just a stickler for words, is I seem to be missing the words App Engine in a few places. So I'm pointing it out. You can kind of get over it with me. It doesn't say App Engine. So how do I know this is really a web app that I'm going to build? It is, trust me. So I'm going to click this button. We're going to get a new dialog coming up here. and it says create a web application project. So we've got a couple of shortcuts. Looks like a standard JSP app that we might create in Eclipse, nothing too special. So I'm going to come up with the project name of GIDS2. I'm going to start with that. Actually, I'm going to say GIDS morning. That'll help me keep a frame of reference for what time of day it is. So we're going to start with that. I'm going to come up with a package name, and we'll give it something like com.ambientideas.test1. That looks good enough. Test01, that's a little better. Leave it in the default location. Use Google Web Toolkit, use Google App Engine. Aha, here's the first little inkling that you get of why it requested the two things. Now, it's not explicitly required. You can uncheck the box, but since this is a unified plugin from Eclipse, it offers both benefits and, in fact, gives you different templates for the web app, whether you choose box 1 or whether you choose box 2. So turning those on and off controls what template is instantiated. Now, for our simplest run-through, I'm actually going to turn off the Web Toolkit because I don't want to add to the complexity for our first couple of steps. I'm going to stick just to the App Engine itself. So Google App Engine, you notice something else at this point. It has the ability, a great ability, to work with multiple versions of the SDK. I have never seen a toolkit in its incubation first couple of years that has had as much foresight for working with specific legacy versions of the SDK. You think, oh, well, Apple, maybe you came to my talk on iPhone yesterday, they push you really hard to chase that latest SDK. Google, on the other hand, actually gives you a lot of opportunity to work with the older versions. They do not force you to chase that tip.release. You can work with any of the existing versions already out there, and in fact, if you have one of the older SDKs, it will, in fact, when you upload your app to the App Engine cloud, use the appropriate version of their SDK to host the app. It's a really neat kind of smooth, seamless, no configuration point for the metadata to go up when you upload your app. So if I'm using 132 for the SDK here on the local box, when I upload my app to the cloud, it automatically knows to also deploy it to a set of 132 containers. So there's absolute symmetry for what you're doing locally with what happens up in the cloud. So once I've got the App Engine checkbox, I'm going to kind of come up with a basic app at this point. I'm going to click Finish over here. And that's going to generate. I'm going to do a little zoom out here for a second, go back to full screen. I've got an item over here in my left window, Test Google App Engine. So let's kind of browse through the folder for a second, see what we've got. What's the contents of this? I'm going to expand it nice and large for you here. Make the column a little bit larger. Do a zoom in. Let's start taking a look at what's in here. What we've got is a servlet. And yes, that is the core foundation of what you can do with Google App Engine. It is a servlet container, not a JEE container, not a full managed container like that, but simply a servlet container. So the first example that it gives you is just a hello world servlet. You also notice a file in here, JDO config. And if you've ever worked with any of the persistence frameworks like JPA or JDO, you're going to recognize this. There is no Google-specific flavor to these from the configuration file. You're also going to see log4j. So right out of the box, it already supports kind of the basic things that we need as developers. Give me some logging capabilities. Give me some persistence capabilities. It's looking pretty familiar from that. It adds a special symbol node in there for a series of jars pointing to your App Engine SDK. It's got about 13 jars that it points to. We'll look at the contents of those, but it's got a special library node. That's what the plugin, adding the Google plugin to Eclipse did for you. You've got that special library node, and then you've got a war directory. We're going to have a lot more to say about that. You've got an index.html in there. You've got a couple other bits at the bottom. Let's expand out one more time. What have we got in here? The one and only one App Engine specific file, which is kind of nice. They only have one point in which you're really tied to the framework so far from the simple example. The rest are all generic bits from this point on. You could put it in any local web container besides that App Engine specific file. So now, without touching anything, without changing any code, they've really done a great job of giving us an out-of-box experience. I can actually just head up here to the drop-down menu. This is my test GAE1 or my GIDS morning. I did a new instance here. I should have expanded that one instead. Same difference. There we go. There's our servlet. There's our meta-inf JDO config. There's our war. There's our lib. There's our app engine web.xml. I'm going to click the debug button drop-down and choose GIDS morning as the debug profile. So you notice it has the Google icon for the launch on that. There is a special kind of node in the debug configuration windows. It's starting it up. You see in the bottom of the container, the server is running at 8888. So it brought up the web container already at this point. That was pretty easy to do. So we're going to pop over to the web browser, open up localhost quad 8, and there we go. Boring, but a list of the servlet. Hey, it worked. And click and run. Now the thing that's hard to impress you with, but you're going to grow impressed, is we've got a complete simulation of the cloud framework already at this point. The behavior here is pretty much identical, 89, 95% identical to the cloud-based behavior. And I'll show you what those small deltas are. But the neat thing is you can do local development. You can be disconnected. You do not have to have that cloud connection to go through most of the motions of experiencing what Google App Engine has to offer. We can even view some of the administration console bits, and I'm going to show you and take you through all those. They've even got local representations of the cloud storage solutions, those massively scalable NoSQL type of storage solutions. But here we go. Hello world, pretty boring. Let's take a look at the code, though, behind this, just to see that it's very, very generic stuff that we'll know from any servlet-based background that we've had. We've got a couple of imports in the Java file here. We've got a suppress warnings. It's always delightful to see generated code have a suppress warnings off the bat. Did I get any chuckles from that? I'll try. I'm not a big fan of already having suppress warnings in there. But there we go. We've got an HTTP servlet. And I've got a do-get with the hello world being output back to the screen. Now you say, this looks like any Tomcat app. And you'd absolutely be right at this point. It just looks like something I'd host in Jetty or Tomcat. But hey, in the first 7-8 minutes of the talk this morning, we already have a Google App Engine application created. So we went through the code. We went through the development server. I showed you how that worked. And now let me tell you, debugging defaults. Just accept them for the most part. I have not, in working with this for over a year now, I have not worked extensively on changing the debug defaults locally. And I already see a question. Wonderful. So that's a wonderful question, and I actually have special treatment of it, but let me give you the short answer now and then a full detail as we keep going. The short answer, and then I'll also restate the question, are we using Ant? Are we using Maven? What are we using for the build? When you use the generation of the wizard from Eclipse, it does not have an Ant or a Maven build file from that. There are templates that the App Engine SDK comes with that have Ant build scripts, and that is my preferred way, actually, of starting, because ultimately, if I'm going to be serious about delivering this as a product, I'm going to need a command line build so I can use continuous integration. The template from Eclipse does not have a command line build file in it. But you'll find that the template from the SDK looks just like this, but with a build.xml. You can use some of the Python support for the plugins in Eclipse, but aside from that, you do win a little bit on the API side for Python. You have more APIs. There are 2 languages supported here, Python and Java, but you lose a little bit in terms of the IDE support. It is definitely richer on the Java side of the house, which is where our focus is going to be today. Given that they kind of called me in as the Java person, that's certainly my background, that's where we're primarily going to focus, but I will show you a few differences throughout the course that we're going to talk about where that differs and a few things just to keep aware of. And any others? One more, we'll field one more before we get back on track.
Was that server a Tomcat server that was running, or is it a server from Google itself?
Okay, so the server, restating that question, what server is running in the background there when I press the debug mode? It actually is Jetty. Google has partnered with Jetty and has a custom implementation that facilitates some of the limits and constraints that they wanted placed on the container, so it is a custom version of Jetty. It comes with the plugin, absolutely, and it also comes with the SDK. You are not downloading a separate copy of that. That is coming with both toolings. All right, so let's do a little bit more. Debugging defaults, I said leave those where they are. Don't mess with those. Success, we have an application in a local web container. You saw it, delightful. So let me ask this question. This is a two-way conversation on why the cloud, but this is what's worked for me. I have some practical experience that it's actually been very successful for some startups in Denver, Colorado, USA, where I'm from. So this is kind of my life experiences and lessons from that have worked really well. The idea here and where this fits, this is not a universal replacement for every web hosting solution that you have in the past. I do not advocate taking existing, great, working, successful, making money applications and just uprooting them and moving them onto the cloud. There are some limited use cases for that, but our primary focus today is on startup ideas. Where it has just resonated and worked beautifully is from the ground up. And let me tell you kind of the story that goes through. So a couple of guys get together on the weekend, dinner, party, something like that, and we have an idea. Now, what used to happen is we said, we don't have enough money to make this happen. Boy, I wish we could find some venture capital to get this started, see if it actually has any legs. Before all these nice frameworks too, we often had a lot of coding ahead of us too. But now we've got some good software frameworks that make coding up a sample kind of Grails or Ruby on Rails type idea pretty easy. But what about the hardware and the infrastructure and the software to support this and actually host it so that it can be a public-facing application? Well, we used to kind of scrounge up some money, and then we bought some kind of a server. Now, we dreamed of that. That wasn't actually what we ended up ever purchasing with what we could scrounge up, but that was what we kind of dreamed of having. So we bought one. It was pretty successful. We threw some money at that, and then after that point, we had it running. We put an app out there. We coded for a few weeks, and we saw how it worked. Now, a few of ours were actually pretty successful. And this is where it's kind of sad. I actually was upset that we were successful because we had a few things that came from that. One, we had one that actually made the news channel. So they did a little short story, 2 minutes, public interest type of story on it. And the thing is, once we had that news story, we were all excited and watching it on the 9 o'clock news and all that. And our traffic, just went through the roof. But the real problem here was that we had a bad experience for those people on that news night. Everybody's trying with their mobile or their phone to get on this, and we didn't have the capacity. I mean, we had such a small budget for the server that we were able to buy that half the people were basically getting, unserved requests and timeouts for that. So, of course, they're like, man, this product stinks. This is terrible. What are these guys doing? It wasn't our fault. We just couldn't afford the capacity for the one night. And really, that is ultimately the problem that we face and that I think is solved very well by this solution. So in that case, we scrounged up some more money. This is before this cloud solution came into play. We scrounged up some more money. We bought another server at that point. And it was, again, kind of a lightweight one, but we grabbed another $1,000 or so together and got a different one. So woo, we survived. We were able to kind of survive the onslaught. We had a higher base of users now. Still kind of denied some people a good experience from that news event, but we thought we made it pretty good. Then the next thing, the newspaper ran an article on it. So we got a couple, 10, 15 more thousand people that on the morning that paper came out, again came to the site. And what do you think happened at that point? Once again, we didn't have the capacity. So it was actually kind of frustrating because the more publicity we got, the worse the experience was because we wanted a slow growth of new users that were happy with the service. But unfortunately, it happened at 9 p.m. on the news or 6 a.m. when the newspaper came out. And those were kind of our two spikes. And we really couldn't afford the hardware to make that happen. There was no way we were going to be able to buy that third server with just the startup money that we were all funding out of our own lunch money, pocket money at that point. So, lottery or otherwise, lottery withstanding, none of us have won it yet. We do play the lottery in our own home state, but none of us have won it. What can we do? Because we can't afford to keep up this iterative cycle of buying new hardware just for these small news events. And that is where this cloud solution comes into play. It solves both facets at the same time. Success has crowds, but they tend to be very spiky in their nature. They're good because we want a lot of attention on our product, but at the same point, we need to serve up and be serving the requests very well on those news event nights so that we get good friend-to-friend kind of buzz on our product. And the crowds are bad in the sense that they're very quick to jump on our product, but then they're gone. If they have a bad experience, they're out of there. They're very sudden, obviously, with these news events, and the problem is that they're also transient. A lot of the people, even if they have a good experience, are not going to end up using our product. So it'd be a shame to buy a lot of excess capacity of hardware to serve up half the people that take a quick look but then never come back. It's just going to happen. Do I really want to buy hardware to serve those people well, given that they're not going to be long-term customers? So we came up with the idea that it would be great if you could take servers back. We have a very nice return policy at a lot of stores in the US, but it doesn't really hold true for servers. It works well for house goods, but not so much for servers. So it would have been nice if we could do that. The idea that really embodies what we want is pay per use. I don't want to own the hardware. I don't want to worry about what the devices are. If I use more, I know I'm going to have to pay more, but the difference is I want to pay more for a very short period of time. So let me plant that seed, and let's go back to some tangible stuff for a minute. I think that's the brilliant idea, but how is it going to be embodied? So we're going to start talking about setting up the account. How would you actually use this now? So we're going to go back to the mechanics of this. Before doing a real deployment of the product, before you actually send this out to the cloud, what do you need to do? Well, we got the development server running. Okay, you've got a small app cobbled together. You'd like to see it live on the web and share it with some friends. So what is the next step that you need to do? So before a real deployment, you need to do 3 quick things. You need to sign up for Google App Engine. And how do you do that? You start by having a Google account. Gmail, working just fine. In fact, let me go ahead and see the hands for who already has a Gmail account in the audience. Can you hold up your hand for me? All right. That's good. Keep it up. Don't put it down. I should have told you that real quick. Keep it up. And how about also having a cell phone with you today? If you have a Google Gmail account and have a cell phone. All right, so I'm going to pick on you, sir. Can you come on down for just a second? You right there at the end. Yeah, perfect. Yep. So we're going to show you how easy this is to get started, because I think that is really the embodiment of the great part of this app engine. It is so smooth and so easy to do that we're going to go to appenginegoogle.com. I am going to do a sign out. I'm going to go back to App Engine. Let that finish. And sign in as a different user. And here we go. I'm going to let you do the sign in right there for the username and password on that, and do the sign in button, and we are going to get you live on the Google App Engine. In fact, we're probably going to use your account for the deployment of some of these applications today. It's that easy. If I didn't do this, you'd think, well, maybe I don't have time to do it, or it's going to be a little too much ceremony, but this is going to be awesome. Click sign in. It won't take us to your mail account. You're good. Don't worry about it. We're not going to see the web mail. So it's going to say welcome. Here's our terms of service. We're going to say yes, you accept. All it's saying is that you won't serve all kinds of porn and other things like that over it, which I know we won't do in today's talk. We're going to be nice, good citizens. And say, sure, you want to use this free service. You're going to be a good citizen on their service. Once we do that, you're going to be taken into the account for Google App Engine. You think, hooray, I'm there. I can actually put it up in an application. But there's actually one more step to it. We're close. Oh, you already, oh my goodness, this is a complete fail. He's already ahead of us and already has an account. That's awesome in a way. All right, so how easy was it? I'll tell you what, we'll do this. How easy was it? Was it very easy to set up? You had your mobile, you gave in your mobile phone number. You said, here's my phone number. They send you a code over the SMS. You come back to the same page, you type in the code, you're done. That's it. Nothing more than that. Wonderful. Okay, so you already have an app up here. And can you say anything about the one that you've already put up? Did you just dabble a little bit? I'm excited to see somebody already do this.
Yeah, so I've created, basically I was working for a company previously. So I had, they have a platform, a sample application for their platform. So they wanted me to host that application on a Google App Engine. So it was pretty advanced, like Start, Spring, and I think it was pretty easy to put it on a Google App Engine. So that was a successful, yeah.
I couldn't have a better recommendation than that. Coming from somebody I couldn't have possibly known in advance. Wonderful. Thank you. Let's give a hand for setting that up. Thank you very much. I appreciate that. Thanks. Well, that went surprisingly well. I was imagining we were going to have to go through all the steps, and we didn't even have to do that. So there we are. We're up. We're in the app, and I promise I'll sign out and not do anything evil to your account. I promise. You got me on my word up here. So there we go. We've got a list of the applications. So I'm going to go back to the slides for just a second, guide you through the steps that we did not necessarily have to do. You got a Google account. You've got Gmail. You're ready to go. You go to appengine.google.com. You've got the SMS code that pops over to your phone. You type it back in the web page. You're done. Now, why do they do that? They're actually trying to throttle the account signups so that it doesn't just go wild. I mean, they have hardware. For all this story that I just gave you about not buying hardware and we don't have to worry about it, they do. There's still physical machines back there, and you can't just give away hundreds of boxes for free. So there's a nice constraint on this that says 10 applications per mobile phone or per mobile number, period. The interesting thing is you can ask for an extension to that if you're in the billing mode and you're very successful, but even in the pay mode, not the free mode, you are still limited to 10 applications until you make a special request. Kind of interesting concept there. But yet again, you need to be very successful on the platform before they're going to say, oh, sure, we'll allow you to have more than 10 applications hosted for this, even in the paid-for mode. So relatively easy to do. You can only do one per phone number. We've got that. We did the sign up. Hooray, success. So what do you need to do for production deployment next? We've got the account. We've got signed up. We can now start putting the same application that we did from Eclipse out on the cloud. You need to start by reserving an app ID. So I'm going to head out to that appenginegoogle.com. I'm going to be a good citizen and sign out of Yashwant's account. I'm going to sign back in with mine. I'm actually going to log in to my one for apps hosted with Google. So let me show you something a little bit interesting here. Down at the bottom of the screen, what I've highlighted is if you have Google Apps for your domain, which a lot of companies like ThoughtWorks are doing now. I know they're big in Bangalore and some other locations. If you have Google Apps for your company's domain, you can also attach an App Engine account to your domain name and host things at your proper actual domain name as well. The interesting thing is you have a different sign-in URL. They remind you on the bottom, but they don't actually provide any direct hyperlink. So that's what I'm going to do for my account. That was a regular Gmail account that was signed into before. And in this case, I'm going to open up yet another tab, paste this up here, and go to my ambientideas.com account. So here we go. You're going to notice that the sign-in box is a little bit different. It says, welcome to Ambient Ideas. It has my company logo on it at this point, and I'm going to sign in with that account. You notice I'm just using a short username, not the full domain name, since it knows I'm in my Ambient Ideas specific implementation. So there's the apps that I have up and listed, just a couple of ones on this control panel at this point. And if I'm doing a brand new application, so something that I'm starting from Eclipse or from that command line, look at the math. Did anybody notice that for just a second? Anybody noticing the delta on this? You have 9 applications remaining right there. Clearly, Google has a counting issue, right? I'm going to plant this problem, and I'm going to show you exactly what's happening in the background in a little bit. So it's kind of fun to create a little bit of tension there. I'm going to create a new application, though. I'm going to use a kind of a blank start, so to speak, for what we're doing today. I'm going to ask for an application identifier. In this case, I'm going to call it GIDS morning. I'm going to nicely try to align it with my word that I used in Eclipse. This is actually going to control the domain name. If you can see there, it says gidsmorning.appspot.com. So it's building the URL. These are for the free applications not attached to a domain name. They are globally unique names. There's no sub.name with your account or your Gmail account. They're globally reserved. And the funny thing is I speak on this conference called No Fluff, Just Stuff, and it goes NFJS. That's our standard acronym. And just 14 minutes after I got my account for this, when it was the day that they launched Java for Google App Engine, 14 minutes later, I had my account. I was in there. I was feeling excited. And I put in NFJS for the name, and then I clicked availability. And it was already taken. So for an entire year, I was able to kind of whine about the fact that my favorite name was already taken. And finally, just 2 months ago, someone raised their hand and he said, I took it. Am I in trouble? So a year later, we finally found out who took the name. But they are global names. You are sharing this namespace with everybody else. So look at that. Yes, GIDS Morning is available. So I did the check availability. I can type a human-readable description. So I can say GIDS Morning example. So that's just a kind of friendly title. It doesn't really affect the behavior itself. I'm not going to mess with the authentication or the user accounts right now. We'll come back and do a more fun one for that. I'm going to click Save, and it's going to reserve that domain name for me. It's immediately put into service, but it's a blank slate. Now, I am doing this in the order that you have to. You have to come out to the website and reserve this space first, and then go back to your container, to Eclipse, to your Ant build, and then connect these two so it knows what the destination is. So application registered successfully. Okay, we're good to go. And I'm going to head back to the dashboard just to show you that's showing up in the list of applications here. Go back to the top level. We'll see it in the list. There's GIDS Morning right there. And you're going to notice over here in the current version column, none deployed. It's never had an application deployed to this slot. So next, we're going to head over to Eclipse. and we are going to click a different button. Zooming in nice and large here at the top, we're going to click on the App Engine button right there. What does this do? This is our deployment button. Now we've got a couple of things that we can talk about here. First off, GIDS morning does not have an application ID. That was that name that we just reserved. And you notice it prompts me for a username and a password to sign in at this point. So I'm going to do my Matthew M and type in password for that as well. So that's how it's going to do the deployment. I am going to, though, click first on App Engine Project Settings, and I'm going to fill in the same value that I did on the web. There's no drop-down. There's no web service that introspects these. And I've got a version field. It's a string. It is not required to have dots between the names or dashes. You can pretty much go crazy with it, but have a sensible pattern. A lot of people are coming up with the standard dot or the dash notation that we use on a lot of software today. So I'm going to start with just 1-1. That seems like a nice expression of it. So 1-1. But again, it's a string, and you can do whatever you like with it. So I'm going to hit OK. I've saved that in. You notice the warning went away. I've now tied that application ID together. And I am going to hit deploy. And with any luck, I get some output on the console at the bottom. Initializing, updating, doing a little ceremony on the code, do a nice little zoom there for you at the bottom. Writing, uploading, pre-compilation, deploying the new version. I've got the progress bar up here at the same time. It does a poll to see if it's ready and up there and being served on the final App Engine on the cloud. So it pushed the contents up. It's now chewing through it, seeing if there's anything up there, waiting. Hopefully this web container holds up nicely for us. The web connection does. Deployment completed successfully. Excellent. OK. So remembering what our URL was, I'm going to open yet another tab. So let's get one more over here. We've got Google accounts. Let's shut that one down. Let's try to clean our screens up a little bit here. Let's close that one. We've got hello world. We were at localhost. I am now going to say gids-morning.appspot.com. Missed a letter there. There we go. And there is a deployment of the one that we just did. That, to me, is a pretty impressive cloud framework. I mean, we left no step out. From download to ground zero to using the plugin, you just saw in the first 20 minutes or so that we've been having a conversation, you have an app in the cloud. Now, granted, still, the heavy lifting of writing good code and a good app idea, that didn't change. But getting it onto the cloud and hosted on this solution, that was the smoothest, easiest experience I could possibly imagine. So here's kind of a good point for you to ask a few questions. Let me see if there's any hands at this point. There's one. There are, restating the question, are there any off-the-shelf apps that you can already deploy here? Some, but not many. There's some sample ones. I have pointers to links of ones that do like time tracking. I have some samples myself that you can download for the same thing. But nothing great and functional that you're just going to love like a software package or a solution. They're kind of examples. This is a platform for you to express your app, but certainly there are some sample ones that let you see how all the mechanics work here. Another question?
Yeah. How easy is it for these apps to talk to each other? Like suppose I have 2 or 3 applications online at cloud.
So how can these apps talk to each other? I'll again give a short answer now with a lot of detail later. The short answer is that they are sandboxed. There is no cross-app communication from any Java or data standpoint. They are very much separate in that realm. Your primary communication channel between those is going to be HTTP. You can do some bulk data transfers between there. There's some crafty solutions, but you do not have any database level or any Java level inter-process communication between these apps. And looking around, do I see any other hands? OK, great. A couple more. I'll work my way up. There we go.
Basically, is there any restriction on the opening of ports or something like that?
Yes.
Ports are available?
I'm gonna restate that one again for everybody. Limits on the ports that you can open, highly constrained, and I will show you exactly what you're allowed to open, but very constrained on the ports that you can open.
And what is the size of applications that we can
There are pretty significant ones. We're going to go through the grid, but it's on the scale of several hundred meg for the binaries and several hundred meg for the static resources. So that's the general size. And let me work my way up. I saw a few up there.
Is there any possibility to use my own domain name rather than this?
Absolutely. Can you use your own domain name? I'm going to give away then, you prompted me to give away something that I wanted to save for later, but gids.ambientideas.com, I put up a solution at this location, HTTP, there we go. Gids.ambientideas.com, here is a web application starter, a project that we're going to kind of dive into a little bit later. But absolutely, you need to then supply the domain name and add a CNAME record for it and all the ceremony you normally would. But absolutely, there are a few specific shortcomings of it, though, that I will tell you about and kind of give you some caution. But sure, you see that it's serving up gids.ambientideas.com. And then working my way up, I see one up there. How is it installed? It's magic. You absolutely just press a button and it goes up there. And I say that in all seriousness. You absolutely write a local web application and you do not have to deal with any of the mechanics of how that gets onto the cloud platform. There's actually a really complex process in which it's fanning out the distribution using a fiber channel back channel between the machines to distribute the static resources and the binaries to the Jetty containers. But all of that is obfuscated and hidden from your view. All you know is you have something that looks like a traditional WAR web app on your disk. You are telling the SDK or the Eclipse tooling button to send this to the cloud, and it figures out how to do those small RPC calls and push the stuff to the right bits. It is not something that you ever touch directly. Down here?
What's the persistence you have? I know there is no JPA, Hibernate kind of thing. Do you have the database?
We're actually going to go through all the mechanics of using one of those, so that one I want to defer. I'll restate the question. What persistence do you have? And because I have such a big section of material that I want to show you on that, I'm going to leave that one for later because I'm going to answer that in full-blown detail.
Does Google App Engine let me host a site on HTTPS?
Does Google App Engine, you're going to make me give away my fun stuff, but here, well, let's go ahead and do it. Does Google App Engine let me host anything on HTTPS? Why don't I show you instead of tell you? It's much better to do that. I'm going to go back to the tab that we had open for our web application. I'm going to go to HTTP, GIDS morning. One more slash would be nice. gidsmorning.appspot.com. So I'm going to open that one up. That was what we had. And yes, I can simply switch over to HTTPS right off the bat. I do have further granular control over which resources I would like to be forced redirected to HTTPS. So you can be specific in the web.xml and the app config. You can say this pattern of URL I want force redirected to HTTPS so that you don't require everything to go through there. You can be a little bit more surgical, maybe the user-sensitive customer data, but you don't care so much about the static pages or things like that. So you have that granular control. But the part that I was saving for a little bit later, but we'll give it away now, is it does not yet support HTTPS on the custom domains. It is top on the bug list, feature list, whichever you want to call it, and they're working on it, but I can't give any promise or date as to when that'll hit. And for some organizations and people, that's a major, major concern. The logins are still routed through HTTPS, even on the custom domain, but you do not have any control over, let's say, your data page or your information page. Those on a custom domain cannot be HTTPS. They don't have the certificate infrastructure. Down here? It is only WAR structured directories that you can deploy. Yes, only WAR structured directories. What other format were you perhaps thinking of, just so I can give the details? A web service jar. Sure, you ultimately though have it probably wrapped in a WAR, like if you were using some of the newer wrappers that are coming from the Geronimo project and the derivations there. Sure, it's still going to look like a WAR, but you've got a lot of facilities for doing web services as long as they're hosted on port 8080. And over here.
I mean, how many instances of this application will be there at the Google server? So is it a single instance, or
talk about the or cloud?
The beauty about, so I'm going to restate the question again. How many instances are out here? You don't know. This cloud solution, unlike some other cloud solutions, hides the scalability factor from you entirely. That is sometimes good, that is sometimes bad. It's a kind of a balanced scale here. You do not have visibility into the number of instances. In fact, there was a little leak, or in the early days, I kind of like to probe the corners of things. In the very early days of this framework, you could actually get a handle to the JVM and some machine information for which box it was running on. They didn't intend for that to be, but a few of us kind of poked and prodded and found it. They saw that we were doing that and shut that off and returned just a static string for that bits of information now. So they literally have intentionally tried very hard to hide the fact of any identity of a machine from what this is being served on. In the background, they actually have two separate pools of servers that this is running on. And they've got a very high-speed distribution network on the back side of these two pools of servers. One set of the servers is serving up static resources, so your GIF and JPEGs and .htmls and things like that. The other one is serving up everything that's dynamic, the JSPs and the servlet addresses. So even though it looks like it's coming from a single domain and a single pool, there literally is a separate bank of servers serving each of those two different purposes. And that's part of the complexity of that uploader tool. It's doing that split and determination based on file type and a lot of other decisions. It's putting them into those two separate binary pools back there. Now, the problem with this hidden how many servers are out there right now is that it takes a little bit of time, and when I say a little bit of time, 15, 60, 90 seconds, not bad, to react to the demand in load and scale up more servers. Now, I've very rarely, if ever, seen failed requests. So you don't tend to get timeouts, but you get a little bit of degraded performance as they say, oh, our number of requests is shooting up. Give them a couple more servers. It grabs your binaries, uses that secret back channel in the Google infrastructure, and pops another couple of servers that are running it on demand. And the same after a quiet period of number of requests, it drops those back off. But that is 100% opaque. You cannot see that actually happening. And maybe just two more, and then we'll get back to track.
Is there a way the app engine development kit lets me mark static content? Like if I have a bunch of PDFs?
Yes, there is in that app engine specific file, you can control exactly which ones are. But I've actually found in all practicality, most of the time you do not have to. So in the sense of kind of being the Maven guy, convention over configuration, the accuracy is right near 100% of the time for me right now, but there is a facility if you need that ability, which I guess something weird would be if you wanted to serve up a JSP as a static content. It's a developer site, and you wanted to have a .jsp that just shows the raw code and not be interpreted as a servlet. You could absolutely mark one of those files as static content. But I've rarely had to do that. And then the last question before we get back on track. Correct? So let me answer those languages. What languages are supported? Python and Java. But Java is kind of a lie because that's JVM, not just Java. It's certainly anything that's compiled to class files. PHP, number 2 requested feature on the bug list. I'll actually show you that on there. I don't know what their plan is just because there's 9,000, 10,000 votes for that feature. Doesn't mean they're still going to do it, but I've seen some responses by Google employees lately, but I can't make any bold prediction. Ruby, on the other hand, Ruby in the traditional sense, no, but JRuby, absolutely, and in fact, I have some downloadable samples. I've decided just to keep it to kind of Groovy and Java for today, but I have samples in the download packet for this talk that include JRuby implementations. No one has really come up with a very solid, robust set, but there has been some limited ability to do that. The thing is that I'm cautious about saying Ruby on Rails is you have a lot of the things that we've come to expect from Ruby on Rails fall off because of the servlet container limitations and also some of the class limitations you're going to see. So at best, it is a limited approximation of a full JRuby on Rails implementation. It is not a full stack. So let's get back to plant some more ideas. I love the questions. Thank you. Make this talk what you want it to be. I'm here to be a resource for this, so if you want it faster, slower, this or that, I'll change it. So you shape the class to make it a good experience for you, but I've got lots of fun things to say. So there's the control panel. We demoed reserving the app ID. We set the app ID in the version. You remember, you took good notes that it's just a string. You can do whatever you like with that version. But we're going to head back to the control panel and see where that actually starts to have an effect, that versioning. Really, really good foresight on that point. So we've set the app ID. We set the version. What if I changed it after that deployment to a different version? So I'm going to go back over to Eclipse. I'm going to right-click on the properties here on the application. I'm going to go down to Properties, App Engine. I'm going to change that to 1-2. I just changed the string, nothing more than that. I clicked OK. I'm going to deploy it with that App Engine bit. Yes, it prompts me for the password yet again. And deploy. It deploys deltas, though. It is pretty intelligent, looks at the timestamp on the files, uses a small hashing algorithm in the background to determine if it needs to send them again. So when you do the updates, it generally is quite efficient. You notice it says uploaded 1 file, so you can see it very small in the console there at the bottom, just 1. It only uploads deltas where possible. It's not 100% accurate, but at least it's not trying to push tons of jars most of the time, especially jars like log4j or some Commons Bean utils, things like that. Once you push them once, given that you're not incrementing the revision of those, you're not sending those across the wire again. So the application was deployed successfully, and we can head over to the web browser yet again, and we can see, in fact, you know what? I want to make one more code change to this. I'm going to step back. I'm going to go over here and say hello world number 2, because I want to create something that you can visualize. I changed the code. I'm going to deploy it yet again under that 1-2. And there we go. We're going to send it out. I'm already going to hop over to the browser. I'm going to go back to our previous tab, Gids Morning. There we go. And I'm going to head over to the servlet so I can just do a quick refresh on that. It's deployed up there. There's hello world. I'm going to go back over to Eclipse. We'll check again. We'll check again. Here we go. It deployed successfully. It's waiting for it. It's waiting for it to come back alive. Ready to start serving. There we go. It's ready to go. I'm going to go back over to the browser and hit refresh and hit refresh and hit refresh and hit refresh. I changed the version, but the code didn't seem to change up on the server. And this is actually a very intelligent infrastructure. That's not a problem. That's a feature. So what do I mean by that? I mean that if we open up appengine.google.com, so I'm going to go back to my control panel. I'm going to go over to Gids Morning, click on the detail of that. You notice up here at the top, I have 2 things. I have the names of all my apps, and I have the names of the versions. You also happen to notice that it has both showing in a drop-down. You're allowed up to 99 simultaneously deployed. You can individually delete them. They are simultaneously having the binaries up there on the infrastructure, ready and waiting. Now, the one and only one that's serving up as the default is 1-1. And over here on the left-hand side, I can slide down to versions. Makes perfect sense. Click on that. Click on versions, and you notice I have a radio button. I could switch it over to 1.2. I could make that the default. Button press there. I can do a delete on 1.1 just to go ahead and prove that it is absolutely wiped out. We're going to have a little bit more fun with this. Go back over to App Engine yet again. There we go. That's the tab I was looking for. Do a refresh on that. And with any luck, there we go. Number 2. So it has the sense of multiple binaries being up on the cloud, but one being active. Now you say, okay, that's kind of useful. I can see the benefit of that. I could put up a new version and then just transactionally switch over so that the new one was the one that was running. Now, what if you wanted to beta test in advance? So let's do one more loop on the same concept. Let's go back to the Eclipse IDE. Let's go and do a deploy one more time. And let's go to the project settings. And I'm going to be a little bit crazy. Go down here, do 1.3 as the version. So I'm pushing out yet another one. And do a deploy. Push that up. And of course, we're still going to get the number 2 showing up in the list. But what if I wanted to? You know what? I need to change that one more time. You guys are here to catch me. This is pair programming in the extreme. I want to change that servlet to, say, number 3. So we've got a nice identifier on that. There we go. Save. And now I'm going to push it up. Staging directory, creating it, pushing it up, initializing the update, sending it up to the cloud. You've seen this by now. But I'm going to show you something very neat about what they thought about for versioned infrastructure of apps. Okay, deploying the new version. It's going to be live here any second. I'm going to type a special URL here at the beginning, and I'm going to say 1-3.latest, very odd URL. I'm going to do a nice zoom in on that so you can see exactly what I just typed. 1-3.latest dot, and then the rest of the name as it stood. Now, there's not a lot of security around that versioned infrastructure, and that is a request that folks have made. I have not seen activity around that yet. Let's make sure that, yep, successful. Continue, good enough. I'm going to peel off the HTTPS just to get a little bit better benefit speed-wise out of that. Hello world number 3. So you can look ahead to other versions that are not the default version by using this special URL format. But at the same point, I'm not a Google employee, so I can say both good and bad things about this infrastructure, which hopefully makes it a little bit more valuable. That bothers me a little bit, that you could just kind of troll for the new version. There is no protection around these non-released versions that are on the cloud. I have nothing more to add to that to say. But there's no but. So questions. Let me take them again for just a second. What if you have domain changes in the two versions? Excellent question. The data model, the persistence behind it, is assumed to be a very large data store. That's the objective for using this cloud too. Gigabytes, maybe even terabytes of storage behind it. They do not version the data store. There is one instance of that. So if the domain model changes, the new rows that will be written will have the new columns. The old rows will remain without the columns. And your application, literally the Java code that you write, will need to have the if checks to appropriately handle nullness, if you will, of the columns that previously were not populated based on the domain change. But once that schema changes, then it's permanently changed. It's not very easy to drop those columns. Granted, you can make them non-required fields, kind of pretend like you're not using them, but certainly once you've touched the demo app with the new domain model, definitely the structure of the persistence is modified.
Suppose I want to check my log file, that this application has generated. How do I take my log file from the app engine?
I have 3 bits on that one, so that's an excellent question. How do I do the log file? So I actually have a whole formal bit, so I'm going to defer that one because I've got enough material to actually show you how that works. And then one more question over here. Did I see one? There it is. There's a hand.
Can we undeploy a already deployed application?
Absolutely. And in fact, I did that with the 1-1, but just to go ahead and make that extremely abundantly clear, I'll go back and do that one more time. I'm going to go back to Applications Overview. I'm going to drill into GIDS Morning. I am going down to the Versions tab over here, and I can delete all the instances. I can delete either one. So for example, I want to decommission this 1.2. 1.3 looks pretty good. Oh, can't do that. Default version. Highlight the next one, make that a default, select it, delete the non-default version. Yes, delete it permanently, clean it all up. There we go. So yes, I can whack instances and kind of keep that scrubbed up. I try not to leave a whole lot of ones trailing behind. And there is a global delete function too. If you just want to wipe out everything about the app, then there's a global delete function that goes above and beyond and wipes out the data store as well. Okay, so a couple other things that we can add to the mix of knowledge. There's a lot of other materials to see here. You've got the infrastructure, you've got the ideas, but there is a lot more going on with the capabilities of this framework. What else can we do? I want to jump over and show you the domain name, appid.appspot.com. We've got that pretty solidified. Now I want to talk about this pay-as-you-go model. How does this work? Why is this actually a good functioning model for computing? We already do this. I've worked in the billing space for almost 11 years now for cell phones. Certainly here in India and in many of the other countries who deploy our software, you pay as you go. You use more minutes, you pay more. You use less, you pay less. You may have credits already on file, but you certainly are not just paying a flat fee every month. Only the US is the only ridiculous country in which we pay a flat fee no matter how much we use. That's kind of a bad mentality. So we brought the cell phone pay-as-you-go model over to the computing world, and it makes a lot of sense from a spike usage standpoint. Now the interesting thing is, I said history. I love history. Let me give you just 2 minutes worth of it because I think it makes it very tangible. Who came up with this? John McCarthy. John McCarthy is known for Lisp. He is the father of Lisp. Kind of a funny place, and it's a long time ago. When I looked at this and saw his quote and started doing the historical research and following the trail of this, it was once again an idea that came way too soon. 1960, of all points in time. That's a long time ago that he came up with the idea of making computing a utility, a pay for how much electricity you use type model. But it didn't work very well for very long. We went to this whole everybody needs a PC, everybody's got their own unit, we've got all these own boxes, and now we're returning back to the model of kind of the roots of where we have shared servers up on the cloud that act a lot like electricity, where we buy it based on how much we use. Eric Schmidt, though, in the more modern era, is the one of Google, claimed to and attributed to using the word cloud first in the formal sense as we're using it in the cloud computing boot camp today. His quote in 2006 is the one that really started the formal use of that word. So what does it solve? What is this helping us with? Because this is not a solution for every possible web app. It helps on this graph. This is where it helps me. I can afford paying for the usage on the green line if that was how consistent it was. I could buy hardware that satisfies the green line of active users. What I cannot afford is to offer quality service on those spikes. In the case of those news events, let me give you the actual numbers. It was 17-1 of our daily usage base. That means I would need to buy 17 times as much hardware as I needed the very next day. Not possible. There's no way that I can afford that. And it really helped us survive those short-lived peaks. That is now absolutely the model that I apply to it, and that's where it makes sense for us with startups and small businesses trying to get going. So command line. Let's switch over from Eclipse and head over to the terminal for just a minute. We've got 2 basic commands that are important here at the terminal that are doing very similar, almost identical things to what's happening in the Eclipse space. We're going to start with the appconfig.sh or cmd, whether you're on Windows or Unix. So this comes with the SDK. So we're going to pop over to our terminal window here. It showcases all the feature sets. It's a time tracking application, meant to be a very ugly, naive implementation so that we don't have any CSS or styling getting in the way of our understanding of the app engine itself. And I'm going to be able to type appconfig.sh, and I'm going to start with help. And I'm going to get a list of commands that I can run on this particular container. Now, it's a little bit crisper to see them over in the slides, but I wanted to make it nice and solid in the sense that there's nothing other than typing appconfig. It's on my path. I've done nothing else. What can I do? This is the list of the commands that it offers to you. The primary ones that I make use of are the deployment, the rollback on occasion. I can wipe something out that was partially deployed, essentially a rewind if it didn't successfully complete, if I broke the connection, if my connection dropped halfway through, I can wipe out a deployment of a particular version instance. I can also get my log files. So I'm starting to address your question a little bit, but I've got even more to come. The log files can be pulled to your local box or viewed through the web console. And this would be our way to be able to retrieve those log files to a local disk. Now, why would you want to do that? They only keep 30 days of log files. There's a lot of constraints around this cloud computing kind of concept. Things are trimmed pretty aggressively. History is not kept for very long. 30-day limit. So if you want to pull the files down to your local box, then you're free to keep them as long as you like and run analysis, run Hadoop jobs on it like we were doing the other day for Apache logs. So relatively straightforward and quite easy to use. Let's actually go give it a spin. So I'm going to show you help, which I did, and then I want to use it to push this app to production. So I'm going to drop back to the terminal, and I'm going to say app config, and I found out from scrolling up here that the command I'm looking at is update. That is create or update an app version. So I'm going to say update at that point. And then it wants to know where is the war location. So if I'm running this, I need a fully fledged, ready to go directory, emphasis, directory that looks like a war, not a compressed .war file. Even though it uses all the web standards, you never send it a compressed WAR. You have a directory that looks like the final compressed version would, but it's raw on disk. Why? Because, again, they're using that delta ability of looking at the timestamps of the files and only sending individually what they need to. So a compressed version would kind of defeat that purpose. They would need to unpack it just to send the files. So you don't need to compress it into the formal WAR, just have the directory structure accordingly. So there is app config update WAR, and that corresponds to the invocation right here, options, action, where's my appdir, and then output file is an optional one at this point. So I need sh. That would be nice. There we go. App config, update WAR, pushing, sending. Doesn't that look a lot like what we saw at the bottom of the console at Eclipse? Absolutely. It's using the same libraries, the same jars that Google ships from the command line version in the Eclipse version as well. It's got the same foundation between it. Deploying new version, going out there, sending it out to the web, 99%, checking again, does a poll. It'd be nice if they had an asynchronous callback for this, but it just polls to see if it's finished at this point. And then finally it'll say, oh, the app is ready and ready to be serving. It's, there we go. It's ready. Uploading the cron jobs, good to go, success, cleaning up the temporary files. So that's how easy it is to use that from the command line. Even further, though, I can use those log commands. Let me do help once again and show you the command for pulling down the logs. It's multi-purpose. Here is my request logs function, and that's when I'll actually use an output as well. So I'm going to say app config request logs. I still need to tell it that WAR location, and you're thinking, why? It's not doing any upload. It's pulling stuff back down. But that app engine specific XML file tells it what version I'm interested in, what the application ID is. So that's still our glue for knowing which one to reach out to on the cloud. And lastly, I give it a name of the file that I want to output to on disk. And we'll call it gidslog.log. Sounds pretty good to me. And it pulls down the full contents of those. It does a download, does a little bit of compression around it. It's reasonably efficient, pulling down the log records, and it retrieves everything. So you have some granularity by date, but for the most part, I just use it to retrieve the whole contents of the file. And if we want to see what the contents of that looks like, it pretty much looks like an Apache log at that point. Host, browser type, all the header information, the specific URL that was requested. So you now have got something that approximates a servlet container that you're traditionally used to using. Cloud looks a lot the same. So a couple of other things. Push to production, we did that. There's the syntax. I put these in the slides just so that you have something tangible later to come back and use. We did the update to the WAR. We pushed it to the cloud. It used the app ID in that specific XML file. We also fetched the logs. We again had to tell it about the WAR directory. And the reason for that is so it knew what app ID to reach out to. We told it the local file to write to on our disk. By default, it pulled everything in the last 30 days that it's had in the log file, but we could constrain it by date if we wanted to. So pause there and take a couple questions. Let me start down right there. I saw that one first.
Can we configure the logs? Format of the logs?
You cannot configure the format of the logs. It is static and unconfigurable. You have no influence on those. The only thing that you can do is change the logging level of what you're writing from your application, but you have no influence on the format itself. It is cached in your home directory in a .dot folder, and it actually hashes the password. So the thing that's stored in your home directory in a .dot Google App Engine folder is a hash of the password that would be sent. So it's cached in that sense. It'll ask for the very first time interactively at the prompt, both email address and password, just as we got prompted in Eclipse. And there's a little bit of disparity in that it's caching from the command line, yet at the Eclipse one, it's prompting each time. And the thought process, I'm not saying I agree with it, but I can tell you the facts of it. The thought process is for a continuous integration server, if you are having it do a push, you're going to need some facility for it to cache. On Eclipse, on the other hand, they're trying to be a little bit more sensitive, saying this is an interactive developer thing where you're actually manually pushing a button and they want you to interact with it and then type in the password.
How about if I want to do some configurations in my server, local server, Jetty, for example? So I want to create some connection pools or anything custom I want to create on the server.
Connection pools, let me just take it up a notch. Anything you can do, like create a connection pool, for example, You do not have access to a traditional database, and in fact, you're abstracted away from anything even looking like a JDBC connection. So you do not have any control at the level of what you just asked for, connection pools and so on. This is a good thing and a bad thing. They are giving you a guarantee of some wacky, huge numbers of scalability, but at the same point, you are giving up, seceding the right to tune those in favor of Google saying, we know better as to how to tune those to run really massively parallel. So you're giving some stuff up, but they're saying, yes, we can still scale to some crazy numbers. And then one more question there.
We actually saw log configuration in the application structure, right?
You saw the ability to configure log for J or logging.properties as you would a logging framework, but what's actually written for the requests themselves as far as the browser and the header information and the version of Safari or Conquer that's coming through is not influenceable, only the logging level in the traditional sense that you would.
One is a transactional log and one is an application.
They are blended into the same set, but they have an appropriate prefix such that you can narrow and determine between the two with a reasonable filter on it and through the web console as well, but they are written to one and the same destination.
Another question, I saw something called as update cron. Can I schedule something to run on the app engine?
You can, and in fact, I have that in the example. I'll show you sending an email every couple of minutes as part of the sample that we go through. Two quick ones. Let me take these real quick. You can, and I also am going to invite one of you as a developer on one of these applications to showcase that. And then right here.
The logs, I mean, is there any way to pull the logs incrementally so that, I mean, at times in this production service and all, the logs would tend to be in GPS?
Yeah, you can ask by a date, so you can say only back to this point. There is a date filter on that command that we just issued.
Day itself, it can run to gigabytes.
Date forward is the behavior right now. So you can ask for a certain date to the present.
Not time.
Not time.
How about DB support?
DB support? None whatsoever. 0, cannot, no, no way.
So what if I used one of, let's say use NoSQL?
Yes.
Is it possible?
It offers a NoSQL solution for data storage, but you must use theirs. You cannot use any other solution. You must use the one that they provide. And then very last, we'll go back on.
What happens if I post my database out of the cloud?
Cannot. They have very tight constraints that limit that unless you have a port 80 interface that you can somehow send data to. That would be the only escape clause that you could get. Any traditional JDBC connection, held open socket, no possibility, not possible. And again, you think, oh, this sounds atrocious. But let me give you kind of a positive light to this. You are making a trade with Google, and they are giving you a promise of some incredible scalability in terms of giving up, conceding control, and in return, offering you guaranteed scalability to some ridiculous numbers. There are apps on here that are serving 10 million requests a day for a couple of dollars worth of cost, and they are guaranteeing that level of scalability. But to give you that guarantee, they are taking away some of your liberties that you otherwise would have had with a free-form application.
How do I see the completeness of a solution without database?
So we'll talk about the persistence. I hear what you're saying. I will show you the persistence. We have an example where we're going to write to a column-oriented store and show you how we would persist it. So great question. This is a Jetty server container. Your great questions got ahead of me, which is awesome. I love that. That's better when you ask than when I have to wait to tell you. The demo dev app server looks just like what we did in Eclipse. Not a whole lot of reason to show you that. I run it at the command line, and it brings up exactly the same container on exactly the same port and looks exactly the same on my box as the button that I pressed in Eclipse. So whether I do this from the command line for an ANT-based build or I press the button in Eclipse, the result is exactly the same using that SDK-hosted copy of Jetty to show the servlet running on my local box. Now the war. I told you this was a directory structure, not an actual .war file, but it looks like from the directory structure an exact representation as we know it. It's got webinf, it's got metainf, it's got the classes, it's got the live directory. All of those things are familiar to you, but no actual war actually being produced. And that's just from that Delta upload capability trying to optimize how much we need to push. They pay for bandwidth, just like everybody does. And even though they're offering this for free, it's not because they're absolutely that benevolent. They actually want to have some business come from this, but they need to minimize their expenses. So one way to do that is to not send the expensive commons bean utils and commons logging and all those jars over and over every time that you push the solution. Now, logging goes hand in hand with having any application that we can even trace what the behavior is going through. And we've got log statements in the one that we're going to execute from here on out. Now, I know we're getting up to our kind of midway break point, so I've got about 2 minutes left, but logging is a perfect way to kind of slide into our pause here at the halfway point. You can use either log4j or Java util logging. You could craftily come up with some other solutions, but let me just tell you from a year's worth of practical experience, stick with one of these two. Either one is good enough. They don't force one or the other upon you. But the interesting part out of all this, I can't believe how they actually made this work. There is no traditional file system in the Google App Engine. So what they've done is hijack system out and system error with some custom prefixes and redirect the contents of what was going to this to the log. So in fact, if I show you the contents of log4j, you're going to be just appalled, but at the same point, it's quite a crafty solution. So we pop back over to Eclipse for a second. I'm going to open up the log4j.properties, do a little zoom in on here, and lo and behold, what are they mapping to? They are mapping to the console appender of all things. But they intercept everything at system out, everything at system error, and write it to that log file. So that's their mechanism by which they're allowing you to use the traditional logging frameworks. No, you're not specifying a file name. No, you're not giving a path on disk. You're routing it through system out, and they're grabbing all the contents of that and putting it into that unified access log.
But can I customize it? Can I add more appenders?
Oh, more appenders and control the format of that. But the destination log, just to be crisp and clear, sure, you can do anything in log4j that you always could for the formatting. But the ultimate log in which these are wrapped, so there's a sandwich on both ends of the logging statements, that you are not in control of, the log4j itself. But there is a prefix, a timestamp, a date, who was the requester, what was the header for the browser that actually asked for this request, what initiated it. That is uncontrollable, but the sandwich in the middle, which is coming from this log4j, you are in control of. And I saw a hand somewhere right here. Do I see one? Oh, there we go.
My question is about SEO. Does it affect SEO page ranks in any way if you host websites on the cloud?
You haven't given up anything as far as the page content. They've imposed no influence on the page content whatsoever. So I can clearly say no, it does not affect SEO in any way. They do not. So redirects. Do they have any facilities like you would have control with Apache, let's say, for example, for a redirect? You could get a little bit crafty and do another mapping maybe for the servlet and actually have 2 entries for the path by which you could access a servlet. But aside from that, no, you don't have a lot of other granular control at the web level, at the request level. So there's your log4j. There's your output that you've got, and the statements look just like traditional log files. But I want to show you something that I now am envious of when I am not using Google App Engine. So over here on the console, so I'm logged into the web dashboard. I'm going to click on Logs, and I'm going to show the contents of the logs in the web interface. And this is really very polished implementation. I want this for my desktop-based applications. And Internet, please hold up. There we go. So I want to see all the logs with a given error level. So I've got a drop-down box for that. I've got a nice expandable Ajaxed view. There's the request. There's the browser that was asking for it. There's the URL. No handlers matched it. Here's an expensive one down here at the bottom. This was the GIDS morning request. This started a new application process and loaded my app for the first time. So you actually get to see some automatic bits that were added to the logging that you didn't even ask for. Oh, that was the first request, so it had to warm that one up in the servlet container and actually compile that, so you get some insider knowledge as to why that request took that significant period of time. In fact, I'll do a little bit of a expand on the font size there for just a second, and you can see that that was 777 CPU milliseconds on that one. So you can filter by that. It also has a couple other search capabilities. It has a filter where I could say fave icon just to show you a hit for the ones for that. I can do it as a regex, get the hits between there. filter it based on a certain date range in the log file. So when I said I really want this from my non-Google App Engine things, this would be great to have just as a part of Tomcat these days. I would really love to have that. And you can even further narrow it down to all, further widen it to all requests and not even care about whether it's a logging level one. These could just be the straight up static resources as well. So I can do the all requests for that. I can clean out the regex once again and view everything that was requested. So there we go, icons and servlet serving. So we are at our pausing point. Let me tease you with what the next thing is, and I know that there's a scheduled coffee break right here in the middle. So the next thing I want to tell you about is the data store, which should get you pretty excited because this is a replacement for the database concepts that we know and love. You give up, again, a few things. This is all about making some trades, but the scalability of this has already been proven. Rather than make some sort of statement, oh, I think this will work, Google has use of this same data store that you can use with trillions of rows and linear performance still being maintained on selects from trillions of rows in a single table. So I think that's a wonderful place to tease you with and for us to take our coffee break. Thank you. There we go. All right, so thank you. Welcome back. Data store, the next fun thing that we get to talk about here. And yes, yes, one quick one. There we go.
How does file I/O play? What happens if I use an API to create a file?
Cannot. And in fact, we're going to cause that problem. We're going to try to run a demo and actually cause that problem and let you see what happens when you do that. But the answer is full stop, no go, can't execute, stops the class, stop the world. If you try to use things that are off the limits.
Is that a Google specific thing only?
Google specific, yes. Not being able to do file I/O is Google specific. Not all clouds. Amazon Cloud Solution allows me having my own disk storage, mount my own drives, write to any file that I like. So that, again, this is a trade that they're saying we cannot give you unlimited automatic scalability if you know where files are located. The opposite, if you need that ultimate flexibility, you can go to one of the other Rackspace or Amazon solutions and have it. But then as we were having in our discussion on the break, you now own more of the problem, which means you need more Google knowledge, Google intelligence, whereas they're giving you their benefit for free, making the trade with you to take away some of your privileges and rights.
The way I'm looking at it is what actually sits on the App Engine is not my real code. It's something with my code plus Google's instrumentation.
It is not modifying your code. It is modifying the servlet container. So restating that once again, Google doesn't really modify your code for the app. Where they have worked all their magic is by taking away things from you and by tuning the Jetty container with the custom instance for the runtime behavior. So you still have a determinate.class file for the methods that you compiled, but the servlet container behavior is where the modification occurs. So let's get the data store under our belt for a couple of things. We've got a lot of other cool technologies to build on. We've got a good foundation. Now I've got a lot of neat things that I can add on for this. So it's nice to have this as a vocabulary. Data store is your one and only place that you can store arbitrary bits of data. It is not a file system, per the question literally that we just had, timely perfect. It is not a relational database. It is in the category of a NoSQL solution, and it is a column-oriented store. Now, column-oriented, that's kind of a funny phrase. It's kind of loose, and it sounds like we're dancing around what this actually is. But you know what it actually comes out to be? This is my definition, and some people are starting to pick up on the same thing. It is a list of maps of maps. Let that sink in for just a second. A list of maps of maps. And you notice I don't have any of the normal Java angle brackets for strongly typing it. That is a funny data structure. List means it has order at the topmost level, like a table. So to draw some artificial parallels for just a second. A map says I have a key and some arbitrary object as the value. Absolutely. Every row has a unique identifier that is constant throughout its lifetime. And once I'm on a given row, unlike a schema-oriented traditional database, I have name and value, name and value, name and value. And per the question that came up a little while ago, what if my schema changes? What if I roll out another version of the app that has slightly different behavior? With this type of a data structure, think about this for a second. It becomes trivially simple to answer this. The next row that's written just has a couple more name and value pairs. It's not the same constraints that you're used to in a traditional database at this point. It just writes another name value pair. And it actually makes coding to these slightly inconsistent set of rows, old and new, very easy, because all you need to test for is the get of a key from a map and then have an appropriate response whether it does or does not exist. Maybe next time you write that row back for the refresh of it, you're going to write it with the value in that place, but you've just adapted and got a nice little if test around whether it's null for the readback that you do. But it is not enforced from a nullness perspective. You can modify rows farther down. And you say, this sounds like chaos. But think of what, again, you're making a trade here. If we said trillions of rows, which is a real number that is in practice on the data store, trillions of rows, you can't do an alter table statement on that. I think we've all pretty much got a grounding to say that alter table, to add a column to a trillion rows, you might be retired by the time that that finishes, even on decent hardware at this point. So the adaptability is to let you write new rows in an additive fashion that have an altered behavior and then leaves the expectation up to you in the app code to handle that legacy behavior. The one thing that this does add over time, and certainly only having a year of this being out on the Java platform, a full year at this point, the idea of this column-oriented data store means you might have to support every potential old version of those rows. Because what if one lives around, it was written at the beginning of last year, there's no business function reason to read it back until sometime next year. You're still responsible, because we didn't have that alter table type of concept, you're still responsible for handling the nullness of those new fields that you've been writing in the new rows. So you can end up, I'm here to tell you the good and the bad, you can end up with code that is maintaining a little bit of baggage for having to keep in mind all the old potential formats in which you wrote those records. But you're winning something in difference for that. You're getting a scalability that is just almost impossible on any other platform. It is schemaless, and Bigtable, I just love this picture. That's always a fun time to do it. Throw in a picture like that. But Bigtable, yes, this is derived off of Google's technology that they use for Picasa, Google Favorites in the search when you star items, Google Reader, if any of you use that as your RSS reader. All of these are using this as the backing store. And yes, there are trillion and billions of rows in most of these implementations. So it really scales, it works. Now you can use this in a low-level API fashion. I don't like to do this. We were having the conversation over the break, and it's an absolutely pertinent thing to mention. I don't like using the low-level API because it locks me into the Google solution. Now, you're going to have a few things that tie you to the platform. I'm just going to say, like the data store itself, not easily migratable to a different format, but I like to stay away from using com.google APIs. And you say, well, maybe there's a performance benefit. But I can actually tell you from practical experience that it is slight to almost none. So in most cases, I stay at the abstraction level wherever possible and not use the Google-specific APIs. But they do have a low-level data store API. I've got a screenshot of the Java doc for that. I don't use that. My flavor is to use an abstraction. So full control versus lock-in. I don't prefer the lock-in concept because I already have some experience with JDO and JPA. Now these are implemented through a very interesting concept, and somebody was mentioning, oh, they're modifying my class files, for example, going up to the server. And I said, no, that's not true, but I'm going to put a little asterisk and give you the corner case for this. On the local box, if you were paying close attention to what was happening at the console, you saw that it was telling you uploading files, checking this, modifying this particular class file. And if you saw right in the details, you saw the word data nucleus there. That is an open source library. They also sell some commercial solutions, but Google has partnered with them to add this to the SDK. So this tooling is embedded in the App Engine SDK. And what it does is it takes JDO and JPA solutions that you've written and actually transforms the class files to an alternate .class file before it uploads them to Google App Engine. So not quite how you framed. On your local disk, they are modified before they are sent up to the cloud. So they're using your CPU time and your compiler to make this happen. They're altering it to use the low-level Bigtable API. So ultimately, your code is ending up using it. That's why I was able to say that the performance difference is almost non-existent between using JPA, JDO, or the low-level API.
But the concept of Bigtable itself, the way it maps, right? A lot of things are not supported. For example, a lot of constraints in SQL is not supported. It could be there in JPA.
A lot of things are missing in JDO and JPA on traditional databases, MySQL or SQL Server that we're saving to. So even though you've got JDO and JPA, you are working with a subset of those features. Absolutely. You cannot do your traditional join behaviors. Constraints are not there in most capacities. So you do definitely have a reduced set of what you can use of those JDO and JPA implementations. And most of that is stopped at compile time or at the bytecode manipulation time, and then given an appropriate error warning that that's not available on this platform. Certainly you could write it in Eclipse, or writing the code, it's legal syntax, but when it gets to this step, you'll be stopped.
On the free part of the Google App Engine, is there a time to live for this data?
There is not. In fact, I can speak, is there a time to live for this data on the free implementation of Google App Engine? And I can actually say that we've got some great apps that we've had up and down and experimented with over the course of the year, and there is no terms of service that terminates or archives off any data on the free level of the platform. They have been very good citizens in offering this free level of service because, of course, they want you to grow and be at the pay level. It's a business, but at the same point, if they played any games with that, you can imagine the exodus would be like, literally cockroaches leaving the building as soon as they pull the trick. So it's very consistent, very durable, and in fact, being active in that community with a lot of the developers on there, I have not heard a single instance of data loss, rows dropping, data being changed. I have heard not one word to that flavor. So that's a good silence. Privacy? Not much in the way of guarantees for that, so there's not much that I can say. You are, in some industries, probably prevented from working on this platform given the absence, healthcare, medical care being one of them that's sensitive in the US. You're probably prevented from using on this platform because you are co-located with other applications on the same platform. They are not giving you any sense of data partitioning. Now, you don't see other people's data, but they are not offering you the guarantee that you might legally need for some of the applications in the US. So you have to think about what the type of app is that you're building, and it may not be suitable for legal reasons, not from a technical standpoint. So your two choices of persistence are either JDO or JPA. And again, this is kind of a peanut butter and chocolate war. Which one do you like better? I don't want to go there, but JDO to me, it seems like the preferable implementation, but that's just my opinion. That's not one that I'm broadcasting on to you. JPA to me just isn't quite as nice of a flavor. So let's take a look at what the code would look like for JDO persistence, and let's save some rows, and let me show you a few things about modifying this data. So we're going to go over to Eclipse, and we're going to crack open this full-fledged example and start looking at a few bits of the code. Now, if you've ever worked with JDO, you're going to be extremely familiar with this class file that we're going to look at. So we'll go full screen on this, zoom in a little bit, and peel through the file. We've got very simple annotation at the top of this. It looks like a Java bean. We've got some persistence annotation. We tell it that it has an identity type of application. So this is our top-level entity in an inheritance tree if there's derived objects. We then have a primary key. That's kind of a traditional flavor that we understand from the database world. So primary key coming next. And then we have the fact that we're using an ID generator strategy. So we're letting Google App Engine populate this field. I would say that 90 to 95% of the applications that we've written and my colleagues have written are letting Google determine the primary ID field here at this point. There's been very, very limited use where we actually want to write our own ID. It makes a lot of sense. It's a globally unique identifier, and it's worked pretty well for us. We're just controlling the other fields. So we typically write it out as a long. It's also constrained by the entity type. So it's entity plus ID is the unique identifier for that object. I've got some just traditional fields, a float, an employee name, a date, Pretty simple at that point. Getters and setters appropriately. A constructor for convenience sake, but not required, that accepts all those parameters at that point. And a nice toString at the bottom so that I can output this in a usable form to the log to kind of give you a full-featured example. So this is just a very naive implementation of time tracking. And we're going to run this app at this point and see what it looks like on the full container. So here we go. We've got time tracked, and I'll show you the user interface page that corresponds to this, but probably just as easy to go ahead and push it to the cloud. So I'm going to do the deploy App Engine project, and I'm going to look at the App Engine project settings. What do I want to send it to? I'm going to send this to, why don't I just reuse that same application ID? Sure, I can just start sending different apps. This might lead to you kind of thinking for a second, whoa, you're going to reuse that application ID and just deploy a wildly different application? Sure, for the sake of development effort, I tend to keep one application ID reserved, what I just use for kind of my everyday experiment. Try this app, deploy this app to it, switch to this app, doesn't really matter. Sure, there's some lint and dust collecting as far as the data persistence goes between these different tables that I'm writing, but it still works out okay. So yeah, you can just radically switch from one application to the other that you're deploying using the same application ID. Now, I'm going to go back to just 1 as the version number, kind of an easy place to go with. And I'm going to add that in. I've got Google App Engine. The web.xml is missing. Oh, that's right. I'll hand set that this time. So I'm going to deploy this one from the command line. That was what I wanted to show you. I wanted to do a deployment from the command line. So I'm going to expand webinf. Where is this saved, though? That's what I wanted to show you, is the contents of the file. Even though I'm setting that in Eclipse, even though I use the wizard, nothing is saved metadata in Eclipse files specific to App Engine. It's all written out to this App Engine web.xml. This is the app container specific file, and you'll see in here it's quite simple what it's actually writing to. Here's my application ID right there, and there's my version number string. So that's where that stuff is actually persisted. There's no Eclipse.settings that's containing that we need to worry about. Even when I change it with the Eclipse right-click properties, it's writing out to this file. So I had this at the command line. Zoom back out. This is the directory that we're sitting in for that project. You saw that I did the upload just beforehand, so I'll be efficient and just make use of that. That was the upload that we did from the command line tool. So that is being served up at Ambient Ideas demo1.appspot.com. How do I know that? Because there's that name of the application ID. Go over to the browser. Let's hit up that address. Take a look at this app. And there's a couple of things about it. First, we're going to do a add time worked. So it's going to use that persistence object that we just declared, that time tracked, and we're going to submit it. And you notice I have security around this. I'm going to show you how that works in just a second. I'm going to sign in with this address at this point, and it's going to let me in. I've got myself marked as a user of the system, so it'll let me into the application. I'm going to add time. So it has a security framework, even out of the bat. You don't have to put up any jars or additional jars. It's got a basic security. Very naive page, but I didn't want to clutter it with any style sheets. We want to just stay close and true to the App Engine. So how about we say 15 hours, and this is our morning work at GIDS. Click on New Time, so we're going to submit that object. You notice it recognized me here in the user construct at the top. I outputted it to the page just to show you that. I'm going to view the time worked, and I don't have permission to access that. There is both a user and an administrative level role, just a granularity of 2 sets that you get for free out of the box. I really like that functionality. Granted, a lot of applications need richer roles. I understand this. But for a getting started, bootstrapping, weekend project, having that out of the box is an amazing feature. So I'm actually going to tab over to my Camino web browser instead, because I have this one already signed in as an additional administrative user if it's still got me hanging out here. So I can go over to the view time worked at this point if I'm still signed in as that. So this one was signed in, this browser was signed in as an administrator, and there is our entry that we just persisted. So there's a few things I can show you about this. I'm going to go back over to my Safari side of the house, and I'm going to go to the administrative console. So there's a specific URL for this, and again, this is saved in the slides here. So we've got an administrative console, but it's easier to navigate to from the application dashboard. appengine.google.com, click on Ambient Ideas Demo 1. navigate over here. The version that's currently deployed is number 1. That's what we just sent it to. And there is a Datastore Viewer over here on the left-hand side. So this big table implementation, also known as Datastore, that being the formal name, has a viewer for the data. And so this is kind of our SQL interface without having a formal tool, because any of the MySQL type tools or SQL Server tools, JDBC tools, do not work with this platform. So they have their specific viewer. You can run your own selects. They've got their own query language. You can do by kind. You can do your own free-form query. They give you some help on that from time tracked. And you could do a where clause where ID equals, and let's see if we can try this on the fly. We'll see if I get this correct from memory. Just a single equals in that case, probably. On the fly is always stressful. So we can filter down to results like that. But the biggest one that I use this for is just to select by kind. And that is the whole category of everything under a particular entity type. I can drill into a given row here and then look at any of these individual fields and make modifications to the domain name, so gmailsomething.com, save that, change the data type of the field, null or string. So you see how this kind of embodies the map-like view? I mean, you can make a little bit of a stretch in your mind and see that this is showing key and value, that's kind of the display in the form. And I told you that it was a list of maps of maps. So there's a primary key up here at the top that's immutable. You see the entity key at the very top. You notice this is not an editable field. That's that auto-generated entity value at the top. And that's what's persisted for everything globally, uniquely. And that one stays for the lifetime of this row, no matter what I do to the values in between. That's an immutable field at the top. It actually creates the structure for it the first time anything persists a row using this. So the very first time that I saved it, the structure is created. There's no SQL command to build the table as you would in the traditional database sense in advance. It's upon first use that it gets assembled. So there is a few things that are a little bit strange in terms of behavior. We actually find that so that we're not paying that for the performance price when the first user comes to the application site, we go and exercise a few of these things on the deployed instance so that the table is created in advance. Kind of a strange thing to think about, but we do that.
How can we build it with our own local data and push it onto the cloud?
Okay, so how can you fill this with your own data? And there are a couple of bits for that. So we can go over to the Datastore Viewer for this. And we can actually see for a given entity there's a CSV import and export capability. And in fact, let's see, we'll go over here. We can click Create an Entity, click a New Entity at this point, and fill in values individually. Or you see that there's a hyperlink here that says bulk uploader. Now the funny part is they do not have a Java implementation of this yet. And you say, oh, wait a minute. But since it's a bulk uploading tool, the applications end up in the cloud identical. There is no differentiation between a Python application and a Java application from the tooling perspective. So you can use the Python tools to do the bulk data upload to the data store. There's nothing that requires that to be Java specific. There's no visibility between those languages for the data store's purposes.
For example, if you want to store the file as a blob, for example, you want to store the images or something like that, right?
One more time, louder.
File if you want to store.
No traditional file access. So when you say file, there is no slash or slash user directory to put it in. Everything would have to be in a row, so to speak, in the data store structures. So you have a blob field that you can put into this data store, and it's limited up to 1 meg, and then they have an additional solution, which is kind of strange, so we're going to get to. They have an additional solution that allows you to go up to 50, but this, for a given column, allows you a 1 meg blob as the maximum size of the element that you can put in there. Multi-what? So it is still a single partition. So from a visibility multi-tenant database, you do not actually have visibility into any data other than to the app. So it's actually not even multi-app from the apps that you have listed on your grid here. The instance is spun up per application ID, very tightly constrained, very sandboxed. Just to that. And then one more.
Can we simulate this data store locally for debugging?
Absolutely. And in fact, that's exactly what I wanted to do right now. So we push that to the cloud. What about using the capabilities that we have at our fingertips right now? Remember the dev app server that we can run locally? So I'm going to use the command line for this. So bringing a lot of the knowledge that we've gained so far together, devappserver.sh. I'm going to use that command, and it's also going to ask me, oh, where's the current working directory? That is war. So if I've got that correct, devappserver.sh war, hopefully, fingers crossed. Here we go. It's running at local, hosting on localhost 8080. I'm going to go over to this browser, and I'm going to go up to the address bar, localhost 8080. Open that up. And same looking interface. It's the same copy that we just pushed to the cloud. I'm going to add time worked. Aha! We get to showcase something else, which is always more fun to showcase it real than in the slide deck. On the local instance, it actually even simulates the login. Now, it does it in a very naive form. Rather than actually checking a username or password for a Google account, it just says, supply me anything, and I'll trust it. But it allows you to simulate the behavior. So you can fill in any user ID that you want into this field, and it's always accepted. There's no denial for this on the local box. But it even simulates Google logins. Now, it has a checkbox. When I told you before, in the real cloud, you can have admin versus user level. You have just the two discretionary levels. But on the local dev app server, to say I'm an administrator, just to simulate the two behaviors, you check the checkbox, sign in as administrator if you want the elevated privileges, or you uncheck the box if you want the lower privileges at that point. That's all there is to it. So test at, you know what we'll do, saltmarch.com, just to be a little bit fun with the element that I haven't used before. I'm going to actually make it an administrator. I'm going to do a login for this. And notice it redirected me to the page that I asked for. It maintains what my destination page was. I did not write any code to intercept the login. I did not write any code to finish redirecting to the page that I originally requested. Absolutely framework handled. I'm going to supply a value here, 999, and this is a local test. Click on new time for that. It submits the value, saves it back, takes me to the home page. View time worked, prove that it's actually still persisted here locally. This is a local test with the 999. And in fact, if I go over to my files system browsing here, so this is a folder view on exactly this dev code that we're working on right now. It is actually saved inside the war directory here in a .dot file. So if we expand down and look in the contents of the app generated right there, local_db.bin. Let me do a zoom to make that nice and large for all you folks there. That is the file that is hosting the simulated contents of the data store on the box. And so it is persistent between runs of the application. So if I bring this back, if I shut this down, dev app server, bring it back up, the data state remains the same. It's consistent. It's persisted to this file when I do the rows. So the performance characteristics should not be implied from the local naive implementation to the one in the cloud. That is not comparable. The behavior is identical, but the performance characteristics cannot be inferred from the local to the remote.
I have just a development kind of a use case. Like if an application was already on cloud, as a developer, if I want to work on it, I just started working on it. Is there a way to pull that?
Can you pull an app that's in the cloud back down to your local box? No, it's a single direction. It's up only. It's up only from your box with code to the production site. So there's Datastore in a nutshell. Yes, there's some limits and constraints that go along with this, but I think they've done a great job of giving us a lot of the thing that would traditionally be expected to only be in the cloud. They've given to us on the local box as well. In fact, we have this admin console, so much like, but slightly different than what we saw on the web, we have a local simulation of that Datastore Viewer, of mail, of task queues, the scheduled tasks, the time-based tasks, and look at this, I can still do a list entries. You notice I have a lot more data here than I had in the actual cloud, but there's the 999 that I just had for the test at Saltmarch that I was doing local. This is a local test, so I have a data viewer that approximates the one that I have on the web, even for the local dev server. This is what really impresses me, is that it's not a push and test, push and test, push and test. I can actually get most of the behavior, about 85–90% of the behavior, on the local dev app server. So it's really quite robust as far as that solution goes. So 2 rows with differing columns. I think looking at the time, I'll probably leave this one for a little fun show and tell afterwards. But if I were to modify that JDO data structure, add an additional field to it, default a value for that, and save it back out, it wouldn't have any hiccups for reading the existing rows. If I don't ask for that field, even though it's modified the schema, so to speak, of the data store itself, it's on a request basis. This is a map. If I don't ask for that field, if I don't know to ask for that new field, the application is not impacted in any way, and only the minified form is actually pulled back out. So only what I ask for is retrieved from the data store. So there is really no performance implication of having that additional column, even though I'm not using it with some of the legacy code at that point. So if I were to modify that bean structure, it's relatively easy. So why would I use Google's cloud versus the others? I actually have solutions on multiple clouds, and I'll give you what I think is my use case for when it fits here. We had this conversation kind of at the break with a few of us, but for the benefit of everyone else. The idea is that it's free to start, and this has made a great difference in how liberated we've been in trying ideas. I'll be the first to admit that probably 1 out of 10 of the ideas that me and my colleagues have actually succeed. That's fine. I don't mind mentioning that here on stage. But when it's free to start, it doesn't matter anymore. I can try all 10. We can prototype something over the weekend. We can show it to some business partners or have 10 of our friends try it out. They can tell us it's good or it's bad. And all we spent was a couple of hours on the weekend, and we didn't pay anything here. Previous to this, 5, 6, 7 years ago, we didn't even try because we said we're not throwing $1,000 at hardware or even $200 for the weekend to rent some servers at that point. So the free to start is a huge deal for getting lots of ideas going and seeing which ones stick. The quotas for free are incredible, and in fact, I'll show you the numbers right now. And you don't own the hardware. I don't want to own hardware anymore. So quotas, big deal of what they give you for free. Let's take a look at a few that I think are the most important. So here's the grid. It's published nicely on the web. There's no hidden thing about this. What do they give you? Column on the left-hand side being the free elements, column on the right being the billing maximum. Yes, they have a maximum even if you're paying them money. They have a maximum which you can go to. And you say, well, why would that be? Wouldn't they want to take unlimited money from me if we possibly could? And the thing is, this is a multi-tenant solution, like an apartment building, like a bus or anything else. You need one person not to be a rabid citizen taking all the resources from everyone else. So even in the billing-enabled space, they have a sensitivity that you cannot just hog all the bandwidth, hog all the disk. They can't dynamically respond to it. However, I will say that if you put in a special request and you justify your use above this, they can make adjustments to this in the background and let you go above those stated billing levels. But you have to put in a formal request and state why you want to do that, and they have to evaluate whether they think that's safe. But look at the free limits here. 1.3 million requests at the free level. I mean, I thought that was a mistake at first, but it's not. There are a lot of free apps that were running during the Olympics, the Vancouver Olympics, that were running on this infrastructure, handling pretty fine, and only paying for the delta between the free level and what they actually used. Even when you switch to billing, you get the free amount free. You only pay between free and the pay point. So that's kind of nice that it doesn't change. 10 gig of bandwidth is pretty generous for a free solution, and 46 CPU hours for the free daily quota. Now, I thought this was pretty funny because we had a person about 6 months ago come up afterwards, and they were being very nice, and they said, Matthew, you need to make a correction to your slides. I'm sorry, there's a mistake in them. I said, oh, that happens all the time. What is it? They said, well, there's only 24 hours in a day down the daily limit, and unfortunately there's 46 hours in the grid at the bottom. So we all got a good chuckle out of it, and I explained that it's a multi-CPU system. This is 46 hours across how many ever CPUs are actually serving up your request. But yes, that's essentially like 2 dedicated CPUs during the course of the day. Now, you're only billed for while your code that you've written is actually running in the CPU, and they've got very precise boundaries around that. You do not get billed for the time that it takes to compile your code, warm up the servlet container, only when your code is actually executing a JSP scriptlet, a Java file that you've authored, or a data store query against the database. So they've got very tight constraints around that. That is the time that you're billed for. It is very nice and sharp, I found that it actually seems to be less than I would have expected rather than more. So in many cases, we're still not in the paid mode for this for the sake of CPU time and the throughput. But we are in paid mode for a few of the other things. They have a few teaser elements that make you want to be on the paid level. And I'll show you what those are coming further down the page. For the data store, where we can persist this data, you can do 10 million calls under the free level, a gig of store data, and 60 CPU hours specific to the data store calls. So pretty generous at that point. Mail, they have a mail server already set up to be able to send inbound and outbound to your application, and that is pretty tightly constrained. We have hit that limit pretty quickly on the free app, because if you have 1.3 million web requests, it seems a little disproportionate that you can only do 5,000 emails. So we do find that we exceed that limit pretty quickly and then put that into pay mode. URL fetch is your one and only way to communicate with other servers, other boxes. You cannot just open an arbitrary socket, so URL fetch is your way to reach out, and that is limited, pretty tightly constrained on the free level as well. I like this number. I like things that have 6 zeros behind them. 46 million over there in the billing enabled quota, and we tend to only spend a couple $100s even when we get to that level of it. Image manipulation, they have some vendor lock-in APIs, so full disclosure, it is their specific API, it is not a generic Java one, that allow you to do some convenient things that we tend to do a lot in web mashups. Tune an image, auto-adjust the color correction, rotate it 90, 180, 300, 270 degrees. You can rotate the images. You can resize them from a large size down to a small one to make thumbnails. These are all convenience functions rather than having to bring in any additional library. These are out of the box because they understand that web mashups very, very often need these behaviors. So that's an image API that they offer. Memcache, this is, again, just a memory-based solution for not having to render things. And in fact, the pattern for Google App Engine is to try to encourage you to pull as many things from Memcache as possible. And by that, they do not charge you any CPU time for anything pulled from Memcache, even though there is CPU involved. And that's an encouragement to try to use that rather than calculate the values that you need. It's better to cache them where possible. Instead of grind through a heavy result, just throw it in the Memcache. Inexpensive. You actually lower your usage of Google App Engine, and you get a financial benefit out of it as well. Deployments, no hard limits there, but the final thing that actually does get locked down and is not listed on this grid, because this is the one that shows all the free stuff, is Blob Store, where you can store those 50 meg images that we talked about before. The traditional data store is limited to just 1 meg for any blob element in any of those columns. So certainly we need some ability to store something larger than that. They essentially have a specialized instance of data store with a predefined single key and value just being a blob. No multiple name tables, just key and value. Generated key, blob up to 50 meg being the value. That's a separate table, separate service, and that's only enabled when you turn on billing. So they do have a few things that, as with any free and premium product, that you kind of say, well, yeah, I do probably need to put in the credit card to get to those. But if you don't use that service, again, you're not compelled to turn on that feature. So Blob Store only being available to the billing-enabled applications at that point. So, mentioning a few more things. No hardware, no OS to patch. This is a big deal. If you're prototyping, not having to maintain the operating system is a big deal. I can't say more than that. It's just non-existent. You don't spend any time on it. The network security, the reason that they're locked down, I heard a few people kind of mention with a little bit of a kind of funny look to their face at the break, I can't just open arbitrary sockets, but Google has an impressive infrastructure for network security. And they've said that by locking it down to only allowing essentially port 80 and web services communications, that they can give you that same level of network confidence that they have for the rest of their infrastructure. So rather than opening it up and not giving you a guarantee, they're saying, well, you're constrained, but we have a lot of infrastructure to both protect against denial of service attacks. You can even tune your own blacklist if you like, but they already have some of that in an automatic mode. Now, there's 3 really levels to the various cloud solutions. And I think this allows me to mention when and where Google fits and when it does not. At the bottom of the stack is really infrastructure as a service, IaaS. And that's when you can see that you have hardware. When I ask Amazon to spin me up a new cloud server on their EC2 instances, which I use all the time, I know I have a new machine. If I want more boxes, I literally supply an integer and ask for that many more machines. But at the middle level, platform as a service, which is what Google App Engine is, I do not have a count of the actual machines that I'm using. It's not visible to me how many machines I've got, and that sometimes is a benefit and that sometimes is a detriment. You have to make that call based on your app, but I like not having to know that if I can get away with it. And at the very top of the stack are things like Gmail, Picasa, Google Docs, Salesforce.com was certainly the first implementation. But if you think about that one, that's even one step further. You're not even seeing anything about the scalability. You're not seeing code. It's just a final app. So kind of nice to have that vocabulary: software as a service, infrastructure as a service, platform as a service, very different purposes beneath it. Now, we mentioned the couple of languages that are available on the App Engine platform today. And you notice I cautiously said for the second one JVM languages, because there are solutions in the examples that I have checked in that you can download for this, in Clojure, in Scala, in JRuby on Rails. I have examples for each of those. And so it is truly the JVM platform. Now, it is Java 1.6, and I'll tell you that from practical experience, you would be well advised to run the 1.6 JDK. It does allow for you to do development under 1.5, but be advised that when you deploy it to the cloud, it still is 1.6 that it's running on. And I like the consistency of having 1.6 on my box, seeing the same behavior when I push it to the cloud. So there's no configurability on the remote end. It is 1.6. Jetty Servlet Container. If you've ever worked with this in the past, you'll see a lot of things that are familiar as far as the log and output and behavior. It is amazing uptime. If you look at the grid over the course of the last year, they've had 1 or 2 notable outages. But other than that, it's been better than the actual virtual hosting solution that I pay a significant amount of money per month. I pay a team to keep a virtual server up for me, and it still has had worse uptime than this free level that Google's been able to provide. And they really have some amazing scaling here. I can point you to real figures, real applications running on here that are running millions of users a day on this infrastructure. So it's no longer a you can or trust me. There are actual implementations out there running millions of users through App Engine today. And I think to some degree, we have too many options on our hands for sometimes coding brand new things. I actually find that there's some freedom through these constraints. The fact that I'm not having to decide what web container I'm using, what persistence I'm using, yes, it is locking me in a little bit, but if I'm just trying to prototype a solution or come up with a startup idea, sometimes not having to make that decision just gets me on the path to actually writing the code. To me, that can sometimes be a benefit. So classes that you can and can't use. We kind of referred to these, but let's go ahead and treat it formally. There is a white list of classes in this container for the same reason of file I/O, threads, other things like the drawing of AWT that are on a white and black list of classes. It's published. It's very clear. There's no ambiguity to this. They have it hosted up on the site, and you can see which classes you can use. But mathematically, it's about 4/5 of Java that you have access to. And I find it was very ironic because here's the list of all the classes spinning through it that are on the white list. It's the vast majority of ones. But the statement made by Sun at the time that this was launched for the Java platform was nothing short of hilarious. There was all kinds of remarks being made, certainly by Sun's OSS evangelist at the time, and he said, this is wrong. But if I have that very line of code, you would find that it would run on the local development application container. And that drives me crazy. They are working on this. They are improving it. But it will actually run. The blacklist, whitelist is not strongly enforced on the dev application server. It's only enforced on the cloud implementation. And this has been a big complaint at this point, because this puts you into, if you're using something that you're not confident about the code, this puts you into the mode of where you do the push and test up to the cloud. If you're using an unfamiliar library that you're not sure has any of these violating classes in them. So that I'm a little bit dissatisfied with, but they do have activity for that that is going to simulate that whitelist, blacklist locally. So why would you choose another vendor's cloud? Well, for the same reasons, in fact, the opposite of the ones that we just listed for Google themselves. Better response times. I've actually got some data that I collected just the last couple of days with a 10x factor of the difference of response times for the same request over the course of an hour. So it would take 100 milliseconds or it would take 1,000 milliseconds. And that was common to happen. And they say that that's natural. Why? Why should that be allowable? Because I was ramping up my requests and they were warming up more servers to serve these requests. And so temporarily, they did not fail to deliver the response, but they did it in a slower fashion while they're spinning up more servers as my demand increases. Then once they recognized I had that demand, more servers spun up to meet the need. The response time improved yet again as more servers were helping fulfill the request. But there is some wild, wild variance in the response times at that point. In fact, that is the graph of the use over 1 hour as I increase the demand. That, yes, a 10x factor for some of the requests, a full second instead of 100 milliseconds for those. OS neutrality is another reason to use Amazon or Rackspace for one of the solutions. I think this is great sometimes when we want to choose Linux, Windows. There's certainly no Windows solution behind here on the Google App Engine. This is a Linux implementation underneath. Not that you can see it, but that's what it is. What if you want Windows-specific Samba shares? What if you want MS SQL Server? Absolutely. We've done plenty of implementations. Switch to Amazon. You're not locked to this platform. Use Google where it makes the most sense. Use it where it's really frictionless. And choice of programming language. You only have 2, or what the plethora of the JVM offers you at this point. What if you want to use PHP? That was a great question earlier. Then you need to switch off this platform. What if you want to use any of the other solutions that we've got out there, a full Ruby on Rails stack? Again, use one of the other solutions so you're not locked to it. I think that GAE can have the risk of locking you into a given platform. So I just want you to go in with the full idea that you might be locked if you're using these image manipulation APIs, if you're using the low-level Datastore API. You might have written an app that really is only pretty deliverable on the Google infrastructure at this point. So Amazon, more than pleased with them. There's a talk later today. I'd encourage you as a yin to a yang to this talk to maybe go to that and see the contrast. But I use it. I use both. I'm not just a person who sticks to one of them. They have solutions that are equivalent to the same things that Google offers. They have SimpleDB. That's the same equivalent to Bigtable by most functionality. They've got S3 for storage, which is like that separate pool of static resources that Google serves over a content delivery network. Now, it helps separate it automatic for us. On Google, Amazon, you're making a more explicit decision what to put in each place. But I think that makes a lot of sense. Rackspace has an equivalent bit. And flipping through it, the interesting part is to put it even in your own currency and one that matters to me. Cloud servers of any arbitrary operating system, Windows, Linux, doesn't matter, even multiple flavors of it, the content delivery network, for a price point that's almost hard to imagine they can make any money at. I mean, 1.5 cents per hour starting point for these servers at that point. Literally, 66 rupees an hour, 0.66 rupees an hour for that. That's just crazy to think that you can own a slice of a machine for that little of a cost. So to me, that's the contrast, and I use both solutions. Now, we saw a few things on the dashboard, and it was a lot more fun. I'm glad the internet held up that we could view that live. So I want to kind of rest on the fact that I showed you that real time and instead talk about our final solution of what mail offers. It's an attribute that we haven't talked about yet. Having a mail server is a big deal for a web app. Web applications like to send welcome messages, password resets, notifications when a particular event happens, and absolutely having this makes this a full web app solution. You don't have to set one up or use the one hosted by your domain. You're actually using Google's mail server, and they've got a quota for that service.
Just stepping back for a moment, in terms of whitelist and blacklisted classes, what if some vendor library I'm using for my app uses one of them? How do I deal with it?
Let me give a short answer, and then I'll take the long one in the hallway. But the short answer for the white and the black list is yes, there's a does it play an App Engine page, and some of those for third-party products, if they're using one of those blacklists, if you don't use the class that touches the offending class, then it doesn't trigger the bad behavior. But if you instantiate that class, it will stop the world when it hits that. And there have been a lot of iterations of open source third-party libraries that have cleaned themselves up, saying, oh, we didn't really need to use that. It was just kind of sloppy or convenient programming. And they have started to make themselves aware, especially Apache Wicket, Spring MVC. These have all become Google App Engine compatible based on this whitelist. They have driven those vendors, those projects, to clean themselves up so that they function nicely. Struts, Grails has now a capability for this. And sometimes there's a mode to switch them into such that they choose the classes they use. But it's nice to see that this has enough attention that the libraries are starting to pay attention and switch themselves, clean themselves up so that they are compatible with this platform. So definitely a good one. Email, though, back to this for a second because this is very important. You've got a server set up automatically, and in fact, it's really cool to show you how easy this code is because this is really common for web apps delivery, and reliable delivery of this is a big deal. I don't want to have to worry about retrying a mail send. I don't want to have to worry about any of the facets with mail other than making a simple call. So here is a send mail servlet. Very, very straightforward. All I've got here is a URL. I'm going to get some contents of a page and stuff it into an email body. But the portion of the email is just these 14 lines. I've got a my message. I've got a string that represents the body. I have a from, which has to be an administrator on this particular application. So very important that this has to be registered as an admin of this app. And then I take and set any destination whatsoever. It's not limited to any particular Google domain. So destination can be any email address that you're even retrieving from the data store, for example. Set the body, arbitrary. You can set attachments. They allow for PDFs and bitmaps and images and all that kind of thing. There's no limitation on the attachments. In terms of type, you can go up to 10 meg for the size of the contents of the message. So that's pretty generous for the limits of the size. And from that point, you do transport.send. It's put into a queue, and it's guaranteed to at least be on the mail queue. Now, again, we can't control whether the mail server on the other end is up, but it's guaranteed to be in the mail server queue. There is no failure response to that transport.send. It will put it on the queue. Now, you can have some file I/O or messaging exception if you've got a malformed address or some of the other functional mistakes, but as far as putting it on the mail queue, it's guaranteed to be put on Google's mail servers at that point. So very nice to have that out of the box as part of the infrastructure that they offer. They have a few other services like that URL fetch, and it's in that same page, so I'm going to pop back to the code. But this is your means of inter-process communication between two web apps. Folks asked, war to war, how do I make those two talk? The answer is a web service and putting a URL fetch call between that, making maybe a RESTful or even a SOAP service call between those two destinations. That is your mechanism of getting data from one application to another on this platform, or one app that's on the platform to one that is not on the platform at that point. And you have a 10-second limit for this request. That is a little bit tight. They are looking at moving that up, but I don't, again, know or have any visibility when that will change. But 10 seconds to finish that URL request. So on some really slow responding servers or on some really large pages, we have had a few cases where we've hit this limit, and it has caused us to have a few bits of code where we need to retry it ourselves. And you do have 10 meg for the total payload size. At 10 meg, it will stop the request and truncate it and throw an exception so that you know you've exceeded that size. So you're finding a lot of limits to the bandwidth, but I think they're still within the reason of a decent web application. So showing you the code for URL fetch and showing you the behavior of this. Let's go to the top of this. I kind of glued the two concepts together. You'll see that I set up a URL to grab the home page to my company right here. I did a buffered reader. I iterated over all the lines through it and just glued it into a large message body at this point. I have all this in a servlet that, by the way, I'm also going to introduce the concept of the cron capabilities that this offers, the scheduling. And you're going to find that that's defined through cron.xml, a specific implementation, again, for the Google App Engine. So you do have one more file that we've introduced. And you notice that the capability of this is like the traditional Unix cron in concept, but the destination is URL. And you'll find that through most of the scheduling or task-based services that Google App Engine offers. I like this consistency. It just is a URL, no special interface that I need to conform to. It could be a servlet. It could be any framework response. It could be a .do from struts. It doesn't matter. At that time, it's going to call that address. And in fact, I have over here in the other browser to show you my Google Mail with this running in the background. And if we had the app up, if I click on the inbox, this at 11:14 p.m., since I do have the app up, was the contents of that very page on the cron job. Since we did the deployment, that is actually running. This is the contents of a mail. And again, it's kind of gibberish. It didn't render it in HTML form, but kind of nice from the standpoint that it actually is showing the full contents of that page. So plug this in real quick, and we'll continue for our last few minutes of the talk. Excellent. There we go. So you saw the mail. That's real. That's sending it from the deployment that we did during the course of this talk. So 10 meg definitely fails, throws an exception. Not too spectacular. You can handle that in your code if you want to, and maybe give an appropriate response back in another email. Send another email and say the request was too large. Put something on the log.warn, log.error, and tell the user, tell the system administrator that there's been a problem. There's also a task queue. Now, this doesn't really solve as much as I had hoped when this came into play. This was not a feature that it launched with. This is something that came about in the last 6 months. And the task queue is the ability to buffer and smooth out the work that you're trying to do with the Google App Engine, much like a JMS queue. But you still have the limitation of only 30 seconds per request. It uses the webhook pattern, which is that it grabs the entire contents of an HTTP request, saves it into the equivalent of a row of Datastore, so the whole contents of the HTTP request, and then allows you to replay it to another servlet in a coordinated fashion. So you're essentially grabbing a request, delaying its execution, and then playing it possibly back to a different servlet. But the idea works pretty well and allows you to smooth out the traffic of something that was doing a calculation or taking orders, putting something into the data store. It allows you to do that in a more even distributed fashion. And they are much more generous with the task queue API limits because you're being a better citizen with those. They're going to be a little bit tighter with the real-time requests and a little bit more generous with the task queue API because that's smoothed out over running all night, running all day. You've got a nice load balance to that. The inbound is an HTTP post to that. It's pretty simple, and it takes the whole payload, saves it to the data structure. You can throttle and schedule when you'd like the queue to respond to the elements there. So you can build it up, process them only at night if you like, and you can even control how many you'd like simultaneously working. So if you don't want your application to max out in responsiveness or exceed its thresholds too quickly, you can throttle how many through the scheduling and through the limits here. So all of that to say it's a web-based implementation of something that looks a lot like a JMS queue. So worker, processing mode, I think it's pretty exciting, and I've got a little bit of code to show you on that one. And it's a very neat implementation. It's very classy. So we're over here. We're going to look at the task queue example. I'm going to open up just a couple of the files. Here is a simple JSP page that implemented this. You can see that it's using a scriptlet to call a variable on a persistence object, counter.getCount. And then let's look at the actual behavior of this. Here's a servlet that actually puts this into the queue. You can see that the calls themselves are actually very, very simple. So we've got a queue factory at this point. We can get multiple queues. We can name them. We can separate the data between them. And in this particular case, we're using a key of the URL and then putting in an arbitrary number of parameters that have some meaning later on. Then the one that actually does the work, that was the insertion process from the user end of it. The one that actually does the work, again, is an HTTP servlet. The interesting thing is really no custom interface. We have a do post. So it's taking that message that was saved and saved out to Datastore earlier, or the special queue, instantiating that web request again, and playing it back to a different servlet. So through the do post, traditional servlet, we can do whatever we'd like at that point. We've got a create or increment at this point, and saving the values back out, saving things to persistence, sending an email, whatever behavior we would like to happen based on that task element. So task queues. Can I answer any questions for this one? This is an interesting new feature.
Can this be done to a separate domain?
It cannot. It is limited to this application domain. You're constrained to the same app. You could make a call in here, so let me change that slightly, and say that you can use URL fetch to then make a call with that payload and reshape it to a different domain. But the convenience methods themselves do not allow you or give you any nice functionality to play it against another domain. You'll rebuild a new web request to do so.
Then you're better off calling a local class instead of making another HTTP post, right?
Say that again, please. You are better off making a call to a local class, sure, of course. Because this is a generic solution that is not tied to the Java model. They're trying to come up with ideas that are, where possible, web-centric, language agnostic. Sometimes it causes us a little pain, but I like where they're going in trying to actually keep us closer to standards rather than lock us in. There's nothing here that actually says anything about Google if you think about it from that standpoint. We could arbitrarily put anything in the contents of that. Any other task queue questions before we go to our kind of closing few thoughts? One there? You can only send to one address at a time with the API, but as far as the quotas go, I can give you a different answer. We can come up over here to memcache, URL fetch, mail. Here are the quotas again for the grid. Do a little zoom in on that. This is the quota for the mail calls themselves. Free on the left, billing on the right. You can, here's the message body. They actually keep modifying this. They bump these things up every so often, so they're up to 60 megabytes on the body. It was 10 actually just about a month ago. 5,000 mails on the free level, but 3 million on the paid point. But the pay price for this each is 1/10 of a penny per email recipient. 1/10 of a penny. So pretty darn cheap. So there's the limit for that. Did I see any other hands? And then we're moving on to the next. Looking around. There we go. Can the last part say again? You can schedule a window and a throttle in which the task queue is processed. So you can say only work on it at night, only do 5 simultaneously, but that's as precise as you can go. Window and throttle. Okay. Come back out of that and to the final bits that we've got to talk. So you're still limited to 30 seconds, no surprises. The entire infrastructure centers around this 30 seconds. We saw the quotas firsthand, which is much better again, but the answer is why? Why are they so constrained? Why are they enforcing this? Are they just draconian, imposing Google limits on us? And no, the answer is they're doing this because it is a multi-tenant system. Not just a virtual private server in the traditional sense that we've had hosting before, but literally multiple apps living on the same physical hardware, and they need to have good behavior. Your behavior should not negatively affect your neighbor's behavior. That's the whole reason for these limits. So one citizen cannot have a dramatic impact on the rest. And it is cumulative. I mean, the idea being here that your massive behavior across the entire grid can have effect on hundreds of other apps, not just a single one, because remember, they're using that back channel to distribute your binaries to multiple nodes. Now, they have limits that are both per day. This is kind of interesting. Those are the ones that we saw on the table before, but they also have per minute. You can't just use up your entire day's quota in a single 1-minute spike. They do throttle you and hold you back so that, again, you're being a good citizen on this system. And 30 seconds max per request is the one that's gotten in the way absolutely the most. You saw the grid of those limits, and that was pretty tough stuff to get around. They did lower in the early days. It was very interesting. They lowered some of the elements for the free time for a bit, but then moved them back up. So as kind of the ebbs and flows, the free level is a dynamic bit. We have seen the numbers change from time to time. So don't get too confident on where those free numbers are, but I've seen them remain pretty generous no matter what. They did crank down the bandwidth and the CPU time a little bit, and then they bumped them back up as they added more hardware capacity to these devices. So closing thoughts, really. Costs. I want to give you the precise elements here. So should you use this? Why should you use this? Is it going to cost you much? Great for startups. The pennies per day, pennies per hour. We usually have spent $100, $150 a month for a very successful app on this, and I think that really is a very viable point for money. Security, I have a few concerns to mention kind of in my thoughts for this. Certainly I wouldn't say these things if I were a Google employee. I'm helped by the constraints because I don't have to worry that I have arbitrary points open for a firewall. The built-in authentication is really nice, not to have to think about building in a CG security or Spring security and building my own database for users and roles, but I do quickly kind of outgrow just the user and admin level. I certainly start to want a mid-level manager level, and I want the lowest level employee that has very limited access, and I want the anonymous user. So I find that I do outgrow that security, but it's a nice place to start. And having that built in with no library is pretty cool. Developer roles, I do want to show you that in the browser itself. And you can add multiple developers. They thought this through quite well. So I can take from the console of one of these, appengine.google.com, and invite any other developer with a Google account to be either an admin, which means they can push new instances, or just configure data for any of these applications. So I can slide down over here and go to the permissions, for example, add additional users at this point. You see that if I shrink the font just a little bit, there's multiple accounts on here. This one I don't own. This is me. I've had this shared out. If I flip over to the other side of the person that actually owns this, I can delete the application. So I'm a contributing developer. You can click the invite button, and they get a little email that they click and accept and brings them onto the project at that point. Nice to have that as part of the infrastructure. So that is my thought about security. That's my thought about the benefits. CNAME entries, domain names. You saw me use that real world. I was prepared if the internet failed to not necessarily demonstrate that. But the real world comparisons as the final numbers. And then we will say goodbye for now. Are these limits too tight? Putting this in terms of applications that are already out there, I think, gives you the concrete feeling that this fits just fine. There is not a single element on Twitter that has a blob greater than 50 meg. Because you're already thinking cynically, well, this sounds like some crazy limits. At the same point, there is nothing on Reddit, a reading a website, a technology-centric website and voting website. They don't have more than 72 gig per day on the throughput. So they would fit on the App Engine. They're not on the App Engine, but I'm using real-world examples. Flickr only recently crossed a terabyte a day of traffic. That's the paid level for Google App Engine. So I'm proposing that at least through their first couple of years of growth, any of these applications, these web mashups, these web apps would have been